they used to do operation.
And sir, like
operation part पर आप जाओ.
Any other questions from anyone? The action of herbal medicine is slower but permanent. Yes.
अभी देखो एक एग्जाम्पल तुमको हम यहाँ अफ्रीका का दे रहे हैं. They are not disclosing the name. एक प्लांट है, उसका उन्होंने रस निकाल लिया क्रशिंग करके, और जब बोन टूटा था तो दोनों बोन को सटा करके और उसमें वो केमिकल के दे दिया. हाफ एन आवर के अंदर कंप्लीटली ज्वाइन हो गया. नो सर्जरी की जरूरत बहुत ज्यादा नहीं पड़ी और ना उनको प्लेट लगाना पड़ा, और उस केमिकल से वो हड्डी बिल्कुल जुट गई. आधे घंटे के अंदर बात कहा कि ठीक है, नाउ यू कैन मूव. जिस तरह से फेविकॉल होता है उसी टाइप का कोई केमिकल है जो कि टूटे हुए हड्डी को आराम से जोड़ देता है. Things are there, but we have to work intensive. हम लोगों को रिसर्च करना है, उनको सर्वे करना है, जानना है उसके बारे में. Then only ये.
Sir, it has not been developed very much due to lack of attention towards the Ayurvedic medicine. So we need to develop it first, then only we can think about effective cure through herbal medicines or through Ayurvedic.
आयुर्वेदिक पर ही हम लोग को अल्टीमेटली शिफ्ट करना पड़ेगा. जिस तरह का साइड रिएक्शन सब हो रहा है, एक्सेप्ट सर्जरी पार्ट में एलोपैथी इज द बेस्ट. अदरवाइज वी हैव टू शिफ्ट टू हर्बल साइड.
Yes, thank you sir for this very informative lecture.
अब देखो ना, अभी एक नाम दिया ना पेंडुला. पेंडुला के बारे में उसका नाम ऐसे जिनसेंग है. सो बिल्कुल स्टॉप डेथ. लेकिन अब चाइना उसको पेटेंट नहीं होने दे रहा है. उसने डॉग पर काम किया है और उनका अपना कहना यह है कि 25% तो एज हम लोग बढ़ा ही सकते हैं. अगर किसी का मान लो 75 साल एज है, नॉर्मल लॉन्जिविटी है, उसको 100 साल तक वो बना सकते हैं. यू सी द कैपेसिटी ऑफ द हर्बल प्लांट. कुदरत में फिर आप लक्ष्मण बूटी, आप रामायण के काल में आप जाइए, जब लक्ष्मण जी घायल हो गए तो सुसैन वैद्य के यहाँ से लक्ष्मण बूटी लाया गया और अल्टीमेटली he survived. कुदरत में एक से एक चीज है.
Right sir. So we just need to conserve our biodiversity.
Of course.
Yes.
और ज्यादा जानना चाहिए उसके बारे में.
जी. So thank you sir for your lecture.
So thank you all for present
here. It was
hearing.
a great pleasure to hear you sir. Thank you.
Thank you. चलो खत्म.
Yes, good morning, everyone. Sir has to be the part of some other meeting, so he hustled up and gave his talk with the utmost information that we can gather from him. He provided us about the traditional uses of fish as therapeutics, and this that we are doing it from the very ancient time, since Ramayana and all, what all the um, history and what all about the traditional medication and therapeutics that he talked about. Mm. So we will have to wait for the another speaker. He has not yet joined because it's almost half an hour earlier to his talk. So we have an opportunity over here. We can discuss about, and all the participants, those who are keeping themselves reserved, not speaking, not talking to us, just mere participation with your poster or oral doesn't make a conference successful. You will have to come up with your ideas, your questions, because the forum that we are in, that is Abricon-22, is Applied Biology Research and Innovation Conference. So innovation comes from the creativity, the idea that we have, more information that we can gather from the researchers that are going around, and also when we are listening to these eminent faculties, they have since, like you heard about from Dr. B.N. Pandey, he's already retired, but still he has enthusiasm to talk about what he had been working on throughout his uh, faculty, throughout his life, and still he is so energetic that at this age he come to us and he presented his work, and he wanted us to conserve the biodiversity, link ourselves towards the Ayurveda, link ourselves to the nature, what he exactly means. So I want to know from all the students here, what is your idea on anything related to nature? Either it's Ayurveda, either it's you can go beyond to Ayurveda, linking Ayurvedic and allopathic sciences together. And there are many other things, like we are advancing with biotechnology, ultimately utilizing our natural resources to help human sustain their life. So we are actually trying to increase the sustainability of humans. So in my point of view, I want you all to put your ideas, because this is not like I don't know everything. None of us here knows everything, but yes, something that you must be knowing with the let's start with the traditional practices at your home, your grandfather, grandmother, those used to do at home in certain diseases or in certain kind of illnesses that we had been through, or when one of your family member get ill with certain diseases, what kind of traditional practices, household practices your grandmother, grandfather, or anyone of that age suggests, and it cures the disease. So let us know from everyone else, right? So anybody who want to take the lead?
I would like to say something.
Yeah, sure, Dr. Rashmi.
Such as we use very strong chemicals to dye hair, that is colors,
Yes.
like which have a very high content of chemicals. But
Yes.
naturally, our elders used to use amla to color the hair, and
Yes.
like Rita to wash the hairs, which was good for health also and good for hair also. So I think many of the students might be using this, or might be they are not aware of it. I am
Hmm.
seeing Varsha is there. Varsha, would you like to say something? Varsha Gupta. Okay. Whom else? I think we'll have to pick the students. They'll not speak on their own. They are very hesitant now.
No, Dr. Rashmi, let's see who want to take the lead, because this is, if we start picking them up,
Huh.
I don't know whether they are comfortable
Yeah.
to say, but I want them to come out and speak up. Like Medha Kumari, Manisha Orao, they are very young. They can talk. And Archie can talk about it. Komal, you are a good speaker. Yesterday you presented your work, so you can talk about it. You must be, even if you want to talk in Hindi, it doesn't matter. You can have to express your things. That is the first and foremost consideration in any kind of conference where you can express your things. So here I want, if any one of us can, among us can take the lead. As Dr. Rashmi Tripathi said, that initially people used to use Rita and what all, Amla and Hina for dying. So we can have more prospects on this. Anybody, please take the lead. And whoever will take the lead will get extra certificate, appreciation certificate. This is the platform where you can talk. Akanksha? I think I will have to go with Dr. Rashmi's suggestion. So, Akanksha. No? Are you guys there? Manisha, Medha, Astha, Varsha, Akanksha, Komal, Disha, Archie, Mamta. Are you guys there? Or you guys are just online and you are doing your steps? If this is so, then I can directly close the meeting. This is not of any use if you guys have just logged in and you guys are not interacting, because this is a platform where you can interact as much as possible. Manisha must not be knowing Akanksha. Akanksha must not be knowing Astha. Astha must not be knowing Archie. But here is the platform where you can know each other. You can go ahead. No, Komal, you can speak, please. There is unmute button. You can unmute and you can talk, right? If you are around, you can talk.
Sir, please, I take some timing because I didn't prepare for this. But sir, on this topic,
कोमल
natural
एक चीज
medicine.
बता दें, कोमल एक
Yes,
चीज
sir.
बता दें,
Yes, sir.
यहाँ पर अभी जो हम बात कर रहे हैं वो एक तरीके से समझिए कि साइंटिफिक बात होगी, लेकिन स्पॉन्टेनियस होगा.
Okay, sir.
आप एक्सटेम्पोर के लिए जाते हैं ना,
जी,
कॉलेजेस
जी,
में एक्सटेम्पोर्स होते हैं. यहाँ पर आपको कोई जज नहीं कर रहा है. यहाँ पर बस इतना है कि सिंस हम लोग यहाँ हैं, हम लोग आपस में बात कर सकते हैं. इट्स अनफॉर्चुनेट, या एक तरीके से हम कह लें कि हमने 1 घंटे का टाइम रखा था कीनोट एड्रेस के लिए और उन्होंने आधे घंटे में खत्म कर दिया. हम उनसे नहीं कह सकते कि आप और बढ़ाइए, बिकॉज
जी, जी, sir.
द डाटा ही हैव शोन, उन्होंने सारी बात कही, अपनी हर बात उन्होंने कह दी है. और उन्होंने ये तक बोला कि ये जो स्लाइड है, ये जो प्रेजेंटेशन है, हम आप लोगों को शेयर कर दें, क्योंकि ये प्रेजेंटेशन क्या होने वाला है, आप लोगों के लिए बेनिफिशियल होने वाला है. इसमें सॉरी, इसमें जो चार्ट बना हुआ है, वो चार्ट अगर आप फॉलो करेंगे, जो लोग, मैं ये नहीं कहता कि आई डोंट नो कितने लोग फिशेस कंज्यूम करते होंगे, बट जो लोग भी फिशेस कंज्यूम करते होंगे उनके लिए एक बहुत अच्छा चार्ट है जो बता रहा है कि कितने फिशेस के क्या क्या बॉडी पार्ट्स कंज्यूम करने से कितनी तरह की डिजीजेस को क्योर किया जा सकता है। ठीक है, तो
यस सर।
मैं भी जो भी बोल रहा हूँ मैं प्रिपेयर करके थोड़ी आया था। मैं भी जो पिछले 15 मिनट से बोल रहा था इट वाज जस्ट स्पॉन्टेनियस। तो आपको स्पॉन्टेनियस होना पड़ेगा, ठीक है।
यस सर।
हाँ, तो अभी आपको कोई जज नहीं कर रहा है, यू कैन से। हो सकता है कि आपकी कोई बात हमें सीखने को मिल जाए, हो सकता है कोई बात अगर आपको गलत पता हो तो हम लोग करेक्ट कर सकें। यहाँ पे किसी को ये सोचने की जरूरत नहीं है कि यहाँ सबको सब कुछ आता है या यहाँ किसी को कुछ नहीं आता है।
यस
दोनों
सर।
ही बातें हैं। यहाँ हर किसी को अपने अपने फील्ड में कुछ 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 आता है। अगर हमें सब कुछ आता होता तो फिर ना कॉन्फ्रेंस की जरूरत है, ना रिसर्च की जरूरत है, और फिर ना एब्रिकॉन की जरूरत है, ना आईसीआरआईबी की जरूरत है, किसी चीज की जरूरत नहीं है। बट सिंस हमें सीखना है, आता क्या है दैट डजंट मैटर, सिंस हमें सीखना है तो इसलिए हम बात करते हैं, राइट। तो
यस सर।
इफ यू कैन प्रेजेंट या इफ यू कैन से तो कुछ कहिए।
सर मैं सिर्फ
हाँ
इतना,
प्लीज।
सर मैं एनीथम के प्लांट के बारे में मेडिसिनल इम्पोर्टेंसेस बताना चाहूंगी, जो
हाँ हाँ
जनरली बहुत ही मैंने इस प्लांट के बारे में कुछ रिसर्च भी करी है और मैंने प्रेजेंट भी किया है।
हाँ
तो
जी, बताइए।
एनीथम ग्रेवियोलेंस प्लांट जो है वो एपीसी फैमिली से बिलोंग करता है। इस प्लांट में बहुत सारे टर्पीन्स होते हैं, टर्पीन्स हैं। इसके अलावा इसके साथ फिरेनोकार्बोमेरिन्स भी होते हैं, पॉलीफिनॉल्स भी होते हैं, कार्डिक ग्लाइकोसाइड्स और टेनिन्स भी होते हैं। ये सारे जो भी सेकेंडरी मेटाबोलाइट कंपाउंड्स हैं, ये एंटीबैक्टीरियल प्रॉपर्टी, एंटी फंगल प्रॉपर्टी और एंटीऑक्सीडेंट, एंटी इंसेक्टिसाइडल भी हैं। इवन इन ये जो सेकेंडरी मेटाबोलाइट्स है एंटी इंफ्लेमेटरी भी हैं। और उसके साथ साथ ये एंटी स्पास्मोडिक, हाइपर कोलेस्ट्रोलमिक एक्टिविटी, और इसके अलावा सर ये एंटी एजिंग भी हैं। और ये प्लांट इतना पावरफुल है कि इस प्लांट को हब के लिए, फ्लेवर के लिए यूज किया जाता है, और दूसरे अलावा भी ये बहुत सारा डाइजेस्टिव भी के लिए भी बहुत ही यूजफुल है। तो इसी तरह से सर पुराने जमाने में हमारी ये जो मेडिसिनल प्रॉपर्टीज हैं इसके लिए बहुत ज्यादा यूज होता था, क्योंकि ये स्टोमक के पेन को प्रिवेंट करता था। और सर ये अभी भी फूड इंडस्ट्री में बहुत ज्यादा यूज होता है। और इसी के अलावा सर एक सिरोपीजिया प्लांट और भी है जिस पर मेरी रिसर्च चल रही है। सर सिरोपीजिया प्लांट ऐसा प्लांट है जो कि सिरोपीजिया सर एक ऐसा प्लांट है जो कि राजस्थान में ही नहीं पूरा ऑल ओवर इंडिया में प्रेजेंट रहता है। और इस प्लांट की सर ये बहुत इंपॉर्टेंस इतनी है कि ये किडनी रिमूवल में यूज आता है। और इस प्लांट को ट्राइबल पीपल्स जो हैं वो बहुत ज्यादा यूज करते हैं, क्योंकि ये फूड, जब भी ड्रॉट की कंडीशंस होती हैं तो ये एज अ फूड यूज होता है। इसमें स्टार्च और कार्बोहाइड्रेट्स बहुत ज्यादा प्रेजेंट होते हैं। और दूसरा सर ये एक ट्यूबर रिलेटेड प्लांट है जिसको कि बहुत ही ज्यादा यूजफुल किया जाता है। और ट्राइबल पीपल्स इसको ऐसे यूज करते हैं कि सर इसको खाने से 4-4 दिन तक भूख नहीं लगती है उन्हें। और दूसरा इस प्लांट में इतने सारे कैल्शियम्स और बहुत सारे मल्टीविटामिन भी प्रेजेंट होते हैं। और ये प्लांट जो है सिरोपीजिया का जो मेन ट्यूबर जो है सर, ये ट्यूबर बहुत ही ज्यादा यूजफुल है, क्योंकि इस ट्यूबर में ही मेन एल्कलॉइड प्रेजेंट होता है जिसको जो फर्टिलिटी एक्टिविटी और दूसरे बहुत किडनी स्टोन के रिमूवल में, और दूसरा सर साइजोफ्रेनिया जो डिजीज है मेंटली, उसमें भी बहुत ज्यादा यूजफुल रहता है। थैंक यू सर।
थैंक यू कोमल। देखिए, आपने इतनी सारी जानकारी दे दी जो हम लोगों को नहीं पता थी, हमें पता चली हैं चीजें अभी, है ना। ऐसे ही
जी सर।
उतना ही नहीं, आप बात कर सकते हैं कि ये जो 2 दिन रहा कॉन्फ्रेंस का वो कैसा रहा आप लोगों का, क्या सजेशंस हैं, क्या कमियां रह गई थी। तो हम आगे जो कॉन्फ्रेंस कराएंगे उसमें भी हमें सुविधा होगी। सो यू हैव अ लॉट ऑफ थिंग्स टू टॉक अबाउट।
कि सर
जो
बहुत ही अच्छी रही।
नहीं, इसलिए नहीं कि थी, मैं ये मेरा ये कहने का पर्पस था कि यहाँ बहुत सारे लोग हैं जे, अगर आप पीछे बात करते हैं ना कि कॉन्फ्रेंस अच्छी थी या इसमें ये कमी थी, तो उससे हमें कोई फायदा नहीं होगा, हम इस चीज को बेहतर नहीं कर पाएंगे। आकांक्षा रॉबर्ट्स, ये पिछले साल भी थी हमारे साथ कॉन्फ्रेंस में एंड इस साल भी है। पिछले बार शी वाज द बेस्ट, शी वॉन द बेस्ट पोस्टर अवार्ड, राइट। इस साल इन्होंने ओरल के लिए प्रेजेंट किया। तो हमें इससे ये पता चलता है कि उनको पिछली बार अच्छा लगा था, इसीलिए शी केम बैक टू दिस एंड हमारे साथ जुड़े, है ना। तो हमें एक तरीके से फीडबैक भी मिल जाता है, हमें एक तरीके से वी गेट टू नो अबाउट न्यू थिंग्स कि अच्छा हम इसमें ये चीजें कर सकते हैं, ऐसा करें तो और अच्छा हो। जैसे इस बार वी ट्राई टू ऐड वन concept, Psi art, right? So this year we added Psi art. Similarly, if you want, we can add some other part of it in the near future. कुछ नया चीज हम ऐड कर सकते हैं, क्योंकि आप लोगों के पास जो क्रिएटिविटी होती है, आप लोग अगर आप लोगों से कहा जाए कि डिजाइन अ गेम, नॉट गेम एज इन मोबाइल गेम और समथिंग, बट इफ वी से कि आप कोई गेम सोचो जो हम फिजिकली खेल सकें साथ में इकट्ठा होके, so you can design a game. हम लोगों के दिमाग में नहीं आएगा कि तुरंत कोई गेम डिजाइन करना हो तो क्या डिजाइन करना।
Yes, sir.
हाँ सर, कंपल्सरी
So we will have to think about कि yes, we can add science quiz later on. तो साइंस क्विज तो मैम तब होगा ना जब बच्चे बोलेंगे, जब बोलेंगे ही नहीं तो क्या क्विज, हम क्वेश्चन पूछते रह जाएंगे, कोई जवाब ही नहीं देगा। We need people to talk and nobody is going to judge you over here कि आपको क्या नहीं आता, क्या आता है। हमें बहुत कुछ नहीं आता है, and that is why we are human, we are not God, right? We are human, we need to learn a lot of things, right? हमें पहले when we were early human beings, early man, we didn't know how to burn fire, we didn't know how to hunt, we didn't know how to cook, but with our experiences we started learning, and with our learnings we are now the most advanced animal on this planet. But yet we are destroying this planet. So as a scientific community, when we are over here, we are looking to find solutions for the problems that we are facing.
Yes, sir.
And in the future we will be going to deal with. So, and this can be only done by doing research and by interaction. We cannot interact. How we will send our messages? सिर्फ रिसर्च पेपर लिखने से थोड़ी होगा। बहुत सारे जर्नल्स हैं जिनमें आपने रिसर्च पेपर भेजा, उनकी विजिबिलिटी नहीं है, कैसे पढ़ेंगे लोग, सब तक कैसे पहुंचेगा? तो कॉन्फ्रेंस का कॉन्सेप्ट यही है, टू रीच आउट टू पीपल विथ योर आइडियाज, टू रीच आउट टू पीपल with the kind of problems you are having in your research, so that people can collaborate or people can try to resolve it. People can come up with ideas to help you out with it, so that the research that you are doing is in the larger benefit to the mass, larger benefit to the humankind, and not only humankind, but yet to solve the issues that we are actually creating to the nature, to our environment, right? So anybody else who want to say anything about their experience in this conference, or beyond that, in their life, that is related to something taking us to the traditional sciences or traditional practices that our parents used to do or grandparents used to do when we fall sick or when we get any issues with our geology and those things. Anybody?
Good morning, Pranab.
Good morning, sir. Good morning, sir.
Dr. Nayak here. So
Yes, sir.
it's very nice that you are interacting with others. I was late. I had some academic activities in the department, so we are late a little bit.
We understand, sir.
I was thinking like somehow I appreciate the effort taken by ICRBI, and it's really marvelous. But somehow the number of attendees is a query. It's a concern, I believe, and
Yes, sir.
all of you will be agreeing. So maybe some type of announcement, more reaching the members, reaching to people a little bit more could be useful.
Yes.
Like
Yes, sir.
I have joined because of the Dr. Tripathi. I have joined this time, first time, but I'm really little disappointed that hardly we got the highest number. I believe around 22, 23.
Right, sir.
And that's quite like disappointing. That's what I believe. Something like if we can do something to reach out the people, so that because so nice lectures, and I appreciate particularly those yesterday poster session and the oral presentations day before yesterday. It was so nice. Young people, we senior people, we keep on talking, and but when the young people they speak, and it's nice to hear them. And if we give a little bit of encouragement to them, and to somehow if we can encourage them to reach here or share things with us, that will be nice. One suggestion is came up with a quiz. That's a good idea. Maybe we can think of something like a little more propaganda, more type of reaching people. I don't know how the this type of arrangement, because it was quite long back. I had a talk with Dr. Tripathi, and so I was expecting it's a like seeing the things. It was so nice, well organized. I think Dr.
Dr.
Ravi is
Nair.
ready. Yes.
Yes, Dr. Ravi is ready. I'm going to tell you about. We started this ICRIB 2 years ago, and last year when we did our conference in December 2021, we had around 45 registrations, and with the organizing committee members and the keynote and plenary, we reached around 70 people.
Okay.
So it was a good number, and I
Yeah.
can understand because at that time it was lockdown, so people were looking for the conference to happen in online mode. People were not very much open to physical conferences at the physical site. So that was the reason when we were having more numbers. We tried to outreach because we have a little number of membership right now, because it's a very new organization. So people are still looking to join with us. And in the near future, definitely we are looking to go for a physical venue where we can have this conference. And we are also looking to add members in the society with more and more benefits to them. There is a journal which is already associated with it. So people who are the member of the society will get benefit with the publication in that journal, like APC discount and fast track publication and all those benefits. But for that, we will have to go to more and more numbers. On LinkedIn, when this event was announced, if you can go to the event page, you will see that there were around 100 people who announced that they will be joining us, but nobody registered. And these kind of conference, which is self-sustaining, will have more registrations, because we will add people to the conferences and they are not going to add the value, then it is of no use. And this platform, when we have started, we have looked into the problems with the students, because many students didn't have their what to say, didn't have their conference, and so they cannot submit their thesis. So this is the way we can help. We started to think helping them. They will get conference and they can submit their thesis, because this is the primary requirement for submission of the thesis. And also we decided that more and more students will participate, and so this year we started sci art for that, for graduate means students of undergraduate and graduate level. They can communicate, they can participate, so as to inculcate more science in them, more views towards scientific advancement, nature, biodiversity, conservation, and all. We started this art, and thank you, Dr. Rashmi, for this idea that we can start with. But see, only two art poster turned back. So,
Yeah,
and we
that's a
have tried on
fantastic
many.
idea. That
We
was a
have tried on, yes, we have tried on many platforms. Telegram, there is a group in which around 1,000 people are there, so we put there as well. And in on LinkedIn, around 7,000 people are associated with the profile, but I think 2 or 3 people have came. And also many people from the society, the members from the society, they have not turned up. So we are also looking to restructure the society, just because we need those people who are really interested in doing science and who are really interested in taking up challenges, because this is a challenge. We have to go to the people, more and more people, and share our ideas and tell them that we as a society, we as an organization want to contribute to the prosperity and sustainability of the society. So this is actually lacking. Even many people have registered just because they think that we will give them the certificate without attending the conference. So many people have registered, but they haven't turned up. There are few faculties, few students, they thought that we will give them a participation certificate, just for the sake that private universities and private colleges want. You should have to show your participation in conferences, so that merely for their promotions. So people think that scientific communities are those who are organizing these kind of conferences will help them to get promotion just because they have paid a registration fees. The thing likewise. So these are the shortcomings, but what to do? Let us move ahead with our next speaker. And we expect all the participants to please interact, right? Without your yes.
Before ending this, before starting Dr. Ravi's presentation, I have a small suggestion. Like,
Sure,
I don't know whether it can be executable or not, because it appears it's like a very wide distribution of science, the wide choice. So maybe I am interested only a small part, and not the rest of it. It happens like as you go in science, as you go for specialization. And so my suggestion is, can we have a theme-wise divisions in different sessions? Like one session is one particular theme, so that at
Yes.
least those people who are interested in those part of the science, they can be they can join and they can interact with each other. That could be a good platform, and we can increase the things that way.
Yes, sir. This is a good suggestion, and we have tried of doing so as well. But since the participation is very little, so managing this is very difficult.
Yeah, I
See,
agree. I agree.
if we
Completely
get
agree with
more
you.
and more participation, then we can go for it. Okay, 5 talk on this particular theme, 4 on this, 3 on. Means we cannot do like 1 on this theme, 1 under a heading. We cannot just put 1 talk under a heading. We can have at least 5 talks which are similar. or 2 or 3 talks which are in related areas. Then only people will get.
Even
Yes.
like once I organized a national conference, and I found what I did, I put in one session, I put the senior professor to have a like a invited lecture. Then in the same field who are working little junior faculty or mid-level faculty, they will be giving some oral presentation. And then I kept a few students who will be or having a oral presentation in the same session. And now what happens, the students are benefited that a senior faculty of the same field is listening to them, and they can interact. Like if the senior faculty is asking a question, they can really interact and they can enrich themselves. That's what I thought, that if it is like that way, it can be done. Maybe we can distribute the oral sessions, or even poster sessions can be distributed in a small group, so that like people working in the same field, they will be interacting. Then interaction, I believe, will be more. That's what my suggestion.
True. The national conference that you have done in a physical mode or in
It was in physical mode.
Physical mode. Actually, what happens, Dr. Nayak, in physical mode, what happens when the resource person comes, they stay.
Yes.
But in virtual mode, they don't.
No,
we are really very thankful. We are really very thankful that you have been with us throughout, and it's really very. We are really very glad to have you here throughout, because you have been supporting us, and you have listened to the poster and oral presentations, and you have asked questions to students. Not only asked questions, the answers we have got from students have given us certain insight about what actual work they are doing, because there were many missing links that you have tried to connect yesterday. So this is really good. But in virtual, we have these shortcomings. The resource person that we get, they don't stay for long, because obviously for the reason
they are busy.
it's
an agreeable point. It is.
Yes.
I think we are.
That is why we are moving on to the physical conference. Yes.
We should give time with Dr. Ravi. We should listen.
Yes, sure. So let us move ahead with this. We will talk again with your inputs. So Dr. Rashmi, can you please proceed?
Yes. So I invite Dr. Ravi Shekhar Gadepalli from Department of Microbiology, All India Institute of Medical Sciences, Jodhpur. He is working in the field of virology and molecular biology, serology and immunology. These are the area of research he is working, and he has also done some very good research work. Like he has filed a patent for the kit for RNA extraction to detect COVID-19 by RT-qPCR, and he'll be delivering a lecture on sequencing of SARS-CoV-2 RNA genome leads to identification of genomic signatures and current variants in circulation in Western Rajasthan, India. So I won't take too much time. I would request sir to please start.
Very good morning to all of you. Can you listen to me? I am audible?
Yes, sir. You are.
Yes.
Audible,
oh, okay, thank you. Myself, I'm Dr. Ravi Shekhar Gadepalli. I'm an additional professor in Department of Microbiology. Thanks for giving me this opportunity, Dr. Rashmi. And without wasting my time, I want to enter into the topic. This topic is since we are working here in COVID-19 in All India Institute of Medical Science, and our lab is a regional VRD which caters for both Rajasthan as well as Gujarat. And we have, during the COVID-19, we have given around 378 medical colleges and institutes permission for the COVID-19. And we are also the referral center for this COVID-19, not only for COVID-19, for H1N1, but also for dengue and Zika viruses. So here we are presently doing the sequencing for SARS coronavirus 2. And we are also doing it for extending our sequencing facility towards the H1N1, also for the dengue. And ours is a referral center for H1N1 also. So coming to this topic, we have seen different waves as we have witnessed the pandemic of SARS coronavirus 2 from 2020 March. We have 3 waves which were recognized, and these 3 waves have shown different kinds of variants. So under Department of Health Research, we are here to sequence this SARS coronavirus 2 and to identify its genomic signature sequences and current and to find out the variants which are circulating in our state, that is in Rajasthan. So COVID-19, as you all know, it's a respiratory disease caused by an infection of severe acute respiratory syndrome of coronavirus 2. And it is it belongs to the beta coronavirus. There are alpha, beta, and also gamma viruses of coronavirus, out of which the SARS coronavirus 2 belongs to beta coronavirus. SARS coronavirus 2 is rapidly evolving and RNA virus that is continuously occurring different genomic mutations, and it is spreading globally. So over a period of time, it is accumulating different kinds of mutations and it is spreading globally. So key mutations of the viral genome and possible impacts of these mutations on prevention and therapeutic strategies currently administered to combat this pandemic. So the main reason for why we are doing this sequencing is to find out these variants. And if we can understand these variants at the earliest, we can able to prevent and also prevent the transmission and also help in making the therapeutic management. So prioritizing these genome sequences for better serosurveillance studies and community tracking. So there are seroprevalence studies which are going on to see the vaccine, and also vaccine also one of the inducer for these mutations, and so to see the seroprevalence and the population and how these variants are evolving, we can see through these sequencing strategies. So to understand first about the SARS coronavirus 2 RNA genome, this is the structure of the SARS coronavirus 2. For easy understanding, it is having a 5' and 3' end. It is ORF1A and ORF1B, and also spike protein region, and also envelope region and membrane protein region and nuclear protein region at the 3' end. So these are the structural genes which are required for the structure of this virus, whereas these are non-structural proteins. These are nothing but mainly responsible for replication, translation, transcription of various activities of this virus. So the 2 components are, one is a structural protein, another is a non-structural protein. The structural proteins are spike proteins, envelope proteins, membrane proteins, and nuclear proteins. So why tracking of SARS coronavirus genome is important? As I told you, it is a change over. It is a continuous change which is evolving this pandemic. Still, we are in not completed the pandemic. It is still going on. Most changes have little to no impact of the virus properties. So very, very little changes of amino acid sequences will happen, and these may not have an influence on the virus properties like pathogenesis and also the resistance and also the treatment strategies. However, some changes may affect the virus properties, how easily it spreads, the associated disease severity, performance of the vaccines, therapeutic medicines and diagnostic tools, and other public health and social measures. So these are the most important things which will help in if the virus changes its strategies or it changes its properties. We may affect in the treatment as well as the prevention of this virus. The actions taken and ongoing activities. According to the WHO now, in collaboration with many partners and experts network and national authorities, we have in India, we have a SARS coronavirus genomic consortium that is known as INSA-CoG, INSACOG is nothing but Indian National Association for the SARS coronavirus 2. It's a genomic consortium, which government of India has been dedicated. Around 14 labs across the India have been functioning towards for this sequencing. We are happy to say that we are also part of this INSACOG, and we are also continuously uploading our sequences presently circulating in our region. WHO and its international network experts monitoring changes to the viruses so that a significant amino acid substitutions are identified. So once these significant amino acid substitutions have been identified, then WHO names them as variant of interest or variant of concern. So variant of interest, when it is that some changes have been observed and it might lead to any kind of therapeutic failure, or it might be also a concern for the transmission. So variant of concern, when you will say it is going to be not like might be, it may be associated, means it has been confirmed that it is really affecting the transmission, and it is also affecting the therapeutic treatment of this virus. Then you will, WHO says it is a variant of concern. So as per WHO, there is a variant of interest, variant of concern, and variant of high frequency are the ones which are presently not in circulation. Only the variant of interest and variant of concern are presently ones which are required for attention. So national authorities may choose to designate other variants of local interest and concern. So coming to our role as a regional VRDL at AIIMS Jodhpur, COVID-19 testing. So if we have to see, this is the wave 1, which has been designated from March to December in 2020. So we have seen a peak of cases, that is in the month of July, and where we have around 21,348 cases. So per day we have tested maximum of 1,100 cases. And most of these cases are from the CMHO, that is the nearest the centers of Jodhpur, and also from the AIIMS Jodhpur, the patients attending the OPD and IPD of AIIMS Jodhpur, and also the army recruits. We have an army hospital near to our AIIMS Jodhpur in Jodhpur. So IIT is also one of the central institute which is placed in Jodhpur. So there also the students and the faculty, we are the caterers for the COVID-19 testing. So we have seen a peak around 21,348 in the month of July, and this peak has been declined over a period of time till December, 5,978 cases. So the second wave, it has started in the year 2021, and it started from March to July. And you can always remember, this is the most pathogenic virulent strain of this COVID-19. And we have seen a peak of cases, that is the 24,887 cases were observed in the month of May. And we have tested a peak of around 1,700 tests per day during this wave, and we have also seen a rise of this mortality as well as morbidity during this wave. That is in the second wave, that is called as Delta variant. And the third wave, which is known as Omicron wave, which we have seen from this year only, this year, that is from Jan to March. And we have seen a peak of cases in January itself, that is 13,331 cases. And we have also raised to the maximum testing capacity, that is 1,600 tests per day. And this wave has started very fast, and it is ended in the early March itself. And a decline of cases have been observed in the third wave, that is in the Omicron. So you have seen that Omicron, we have the number of cases more. So total number of tested samples from IPD screening from AIIMS itself, it is 7,493. So total number of positive, you can see 1/3 of the patients are positive for tested positive for Omicron, and for January itself. And other variants we have observed other than Omicron, we have observed that is Delta as well as Alpha variants in this period only. So coming to the whole genome sequencing, presently we have this in AIIMS Jodhpur to update the present variant circulations of the SARS coronavirus 2 in this western region of Rajasthan, and identification of the substitution mutations in the spike protein of emerging variants and mixed lineages. So these spike proteins are responsible for attaching to the receptors. That is, these are the receptors which are required for pathogenicity of these viruses. Identification of particular variant of SARS coronavirus 2 that caused highest mortality in the western region of Rajasthan. So we are also we have also completed the work on Delta variants, which has not only in Rajasthan, it has also given a very good number of deaths in across the world during this pandemic. So we have also seen the Delta variant sequences and identification of common unique mutations that are present in mortality group of patients belongs to a particular variant. So we are also seeing, we are presently working on this idea of common unique mutations which are going to be common for these variants and how these mortalities have been affected by these mutations. So coming to the results, we have a Delta variant lineage, that is Delta clade, remains persistent during the third wave of the COVID-19 in western region of Rajasthan. So even in the Omicron time also, means in the early this year, January to March, where we have seen the Omicron variant, then also we have the Delta variant which is circulating along with the Omicron, and we have seen the maximum number of deaths during the third wave is due to the Delta variant, not due to the Omicron. And B1617.2 and the AY122 lineage of Delta clade remain the most persistent variant of the SARS coronavirus 2 during the third wave of the COVID-19 and among the mortality group. Current variant in circulation in Western Rajasthan is BA2.75, which is called as a Omicron variant. It is the second subvariant. In the Omicron itself, we have BA1 and BA2. And it is the second subvariant of the Omicron which is circulating presently in the Rajasthan. So number of samples belong to the particular lineage of SARS coronavirus during the second and third wave. We have detected during the second wave and third wave, we have detected more hospitalizations and also more morbidity and mortality associated with the second wave than in the third wave. And these are the different mutations which we have come across in all these waves, that is in the first wave, second wave, and also in the third wave. And we have detected around B16172 mutations in all these waves. And it has been noted in these waves. And the third wave, we have not detected this mutation. Total number of mutations present in the spike domain within each categorized of the set samples. So we these bold letters of these mutations are the ones which are present in these variants, and these are the mutations which are responsible for the pathogenicity of the spike protein. So the bold ones, that is the bold changes that are mutations that are going to happen, are responsible for the pathogenicity of this virus, for both the first wave, second wave, and as well as the third wave. So these are the different axial numbers, and we have defining the mutations in the Delta variant, which are in the bold, and as well as in the Omicron, we have in the bold and italic forms. You can see both in a bold and italic form. These are the different variants which are present in the Omicron, and these are the variants which are Delta variants which are present in the bold form. So these are different axial numbers which we have submitted in the INSACOG from AIIMS Jodhpur itself, and we found that these are the variants. That is Delta variant, which is a variant of concern, is first detected in India and has got more pathogenicity, has more spike protein mutations than the Omicron as our Alpha variant. So we constructed the phylogenetic tree and to see how these variants are evolved one after the other over a period of time. And by these construction of these phylogenetic evolution tree, we can understand how these recombinations are taking place inside the virus itself. And over a period, they are evolving into a more pathogenic or more virulent strains. So when you have to observe these recombinations, the presence of large number of variants in circulation within the same host population activates an additional mechanism known as recombination for the virus diversification. So if you see, the recombination involves the formation of chimeric molecules from parental genome of mixed origin. So for this recombination, it has taken place from the different viral strains, which has been originated from early, from 2020 March till now. We have emerged into Omicron subvariants. So Delta variant, coming to the discussion of my presentation, Delta variant remained the most deleterious variant in terms of mortality in western region of Rajasthan. The RNA genome of SARS coronavirus 2 undergoes potential interlineage recombination events during its evolution. So it is an intermixing of the viruses. That is, since at a time there are multiple strains are circulating and multiple variants are circulating, so intermixing is more probable, and it can lead to recombination, and more successful recombinations will form into more virulent and more pathogenic strains. So genomic surveillance of SARS coronavirus 2 is the only approach to rapidly monitor and tackle emerging variants of concern, that is variants of concern of the COVID-19. So we have to continuously adopt this genomic surveillance, and we have to see not only for the SARS coronavirus 2, but also for other viruses which are presently in this endemic in this place. So last year we have an outbreak of Zika along with dengue, and now this year we have a dengue outbreak. So a genomic surveillance for these viral pathogens is highly required, and which will help us to understand the evolution of these viruses. In the present study, the Omicron is the most transmissible variant to date of all age groups, but associated with decreased pathogenicity, which has been encountered with a low fatality rate and low morbidity, low hospitalization rate compared to the Delta variant. So determining the host gene expressions to identify the prognostic biomarkers of treatment efficacy and disease progression would make the efficient genomic surveillance. So these are the methods which will help us to understand the evolution of the virus, and also help in taking the public health prevention strategies. Studies have provided plenty of evidence for recombination events in the RNA genome of SARS coronavirus 2. The pattern of such events would be important in understanding the impact of the evolution of the virus with respect to pathogenicity, and also could also help in insightful direction if the humanity encounters such an outbreak and mediated by positive cells of RNA viruses. So it is like a kind of a lesson. Once we could be able to identify the genomic signatures, we could be able to identify the virus and its pathogenicity in early stages, and we can help the humanity in promulgating, or you are going to make a new strategies for the prevention of these viruses. That's all. Thank you very much for this kind opportunity. And if you have any discussion, any questions, please kindly ask. I'm happy to answer you.
Sir, I have a question.
Yeah, please.
Sir, anyone who suffers from cold nowadays, people say that you are suffering from, means you might be, you are having corona. Sir, is it so?
It can't be. Once you have not tested, you cannot diagnose. In this season, if you see, it is more common that most people are affected by the most of the respiratory viruses. So respiratory viruses are not the only SARS coronavirus 2. We have other respiratory viruses like adenoviruses, we have influenza virus, we have the respiratory syncytial virus, RSV viruses. So there are different variants are there, different viruses are there. So until unless you diagnose a virus, means diagnosing the virus means confirmation of the virus by either by real-time PCR nowadays, or by confirmation by the any serological test. So you could able to identify, then you can able to say that this virus, we are suffering from this virus. You cannot say by the symptoms itself it is the virus of SARS coronavirus. Now the symptoms you have seen, it has been emerging from the alpha variant, beta and delta variant. Now it is on the Omicron. The symptoms and the signs have been changed enormously for the virus because of its mutations.
And so one more thing, that is means it has seen that the infection has become very frequent. So is it to do something with corona?
It is, if you see, the cold means, if you are talking about the cold itself, cold can be happen by the 16 types of viruses. As I have named them: influenza, parainfluenza, RSV, respiratory syncytial virus, adenoviruses. These are all can cause the cold. So if you are affected with cold by particular group of virus or particular type of virus, you are immune for at least 90 to 180 days for that virus. And again, there are 16 types of viruses. The other kind of virus can be affecting you again, and it is causing the same kind of symptoms and signs. So you cannot distinguish basing on the signs and symptoms of respiratory infections, basing on the signs and symptoms.
And sir, is a heart attack to do anything with corona infection? Because I heard that many people who were getting cured and were about to be released from the hospital, at the very last moment they had a heart attack and they did not survive.
You see, it is still the corona. It's a long-term corona. They have named it as a long-term corona. Is also there. It's a chronic infection. So whatever the knowledge we have during the pandemic, it is that it can cause the respiratory infection only. So it can also associated with the other infections like GI. It can affect the GI tract, and it is also during immunocompromised persons. The viral infection can lead to the other clinical manifestations, which are going to be more complicated. So it depending upon the immunity of the person, it changes. According to the kind of infection, means the rate of infection which has happened for that person. So it depends upon how it is going to manifest. So again, it is need to be tested. Once it is tested, and it has to be needed to be, the treatment has to be taken under a physician only. So you will able to recover very fast and to not having any kind of complications.
Thank you very much, Dr. Ravi.
Yeah.
I have a question, because I think everybody has the same question in their mind. That is that we have several variants: BA1, BA1.1, BA2, BA3, BA4. These are the variants, sub-variants of Omicron. So my concern is, will there be more new coronavirus variants? First. Second, since virulence is decreasing after every new variant came, alpha, beta, delta, Omicron. So what is your take on it, that the new variants that will be coming ahead, are they more severe? Will they pose more severe concerns? What is your take on this?
So SARS corona, this is one of good question, if I have to say this first of all. And since SARS coronavirus 2, it's a continuously emerging virus. Not only SARS coronavirus 2, other H1N1, any RNA virus is a continuously emerging and continuously evolving viruses. So once you will have an outbreak when the population is not having the immunity for that virus for that particular period, then you will have an outbreak. For example, if you see H1N1 outbreaks happens very common in US. So that is why they take flu shots every year. And regarding this emergence of these variants, and mutations are very common for RNA viruses. So it is going to happen and over for a long, it's going to be a long process. It is going to happen for a long, and over a period of time, the mutations may be emerging the virus into a better pathogenic variant, and it is also a less pathogenic variant. So whatever we have seen after the Delta variant, fortunately, all the variants which have emerged, they have less pathogenicity compared to the previous Delta variant. So we are always, after having the vaccination also, once they started the vaccination also, we know that it is going to be prone for mutation, the virus is going to be prone for mutation, and it can change into its strategies. So where do these mutations occur? These mutations mostly occurs in an immunocompromised person. Means once the virus enters into an immunocompromised host, then only it will have these mutations more than the immunocompetent host. So if a virus affects the immunocompetent person, the mutations are going to be again, the virus is going to be eliminated by the immunocompetent person, and it is going to be like a few days fever or a few days malaise or headache or running nose, and he will be coming back normal. But immunocompromised host, like person HIV, and a person who is very young, and a person who is very old, and a person who is underwent a transplantation, and who is already taking the corticosteroids. So in those people, the viruses are prone for more mutations, and they are going to emerge as more successful and more highly pathogenic. So we have to take care of the immunocompromised people once they are affected with any respiratory infection, and soon we have to start the treatment at the earliest, and to and give them good prophylaxis. If we have not given the vaccination, we have to give the prophylaxis for the immunocompromised people at the earliest.
And one more query I have, Dr. Ravi. We have heard that after every new variant that happened to erupt, we have seen that there is escalation in their number of mutations, their number of means in terms of their lineage, and increased number of mutations, right? So I don't know, it's kind of a childish question. Is there any kind of mutation, or is there any kind of variant which will be having de-escalated mutations? Means the number of mutations that have increased in every variant that we have faced. Do you think there will be any de-escalation in mutations?
De-escalation of mutations is going to be very uncommon, because what we see, we have a wild type in any kind of mutational studies. Even in for humans also, what we will see in the humans, you have the wild type, and the wild type over a period of time, it will be emerging and re-emerging into a different variant. So it will not be coming back to again to the wild type or normalized back, because the population here has been mostly, they have been got vaccinated. Either it is in India or it is in abroad, everywhere you have seen the people have taken, most of the people have taken. It is not that 100% population, around 50 to 60% of the population, whole global population has taken the vaccination. So once the vaccination is already been taken, and means there is a certain kind of immunity prevailing in the population. So if the virus enters into any kind of human being, either it is immunocompetent or immunosuppressed, then what it changes, it tries to find out a change in its structure or its function, so that it can able to sustain in the host. So it depends upon the virus how it changes. If it is an immunocompetent host, then the virus perishes. If it is an immunocompromised host who has not been properly vaccinated or not properly been treated, then the virus undergoes certain mutations, and it tries to come up with, like, it's like a survival for the existence. So the virus tries to find its ways to survive and to come back as again with a new form. I hope I could be able to answer you.
Yes, certainly. And one more question, rather two more questions from my side. One is that people are very dicey that we have already taken 2 doses of vaccines, and why to take booster dose, or should I take booster dose? Because my experience is that when I took the second dose, I started getting knee pain, and it was very severe, and it stays for months, right? But
Okay.
lately it sidened up. So I was very much frightened about whether I should go for the third dose or not, and whether it is going to help me out or not. First thing. Second thing is that since we have hustled and we tried to develop vaccines within very little time span, initially it used to take years, 10 years or 15 years to get the vaccine, to develop the vaccine. I know with the advancing technologies it is easier for us, but again, clinical trials take much time, because when you develop a vaccine, most of the time goes on clinical trials, and most of the vaccines that we have in market have gone till a third phase of clinical trials, and it was launched into the market for use. So is it so that we are ourselves the cause of mutations and newer variants, because we have hustled with the vaccine preparation? So can you shed some light on these two questions?
Yeah. One thing is, you have seen first question of yours is, if I have understood well, you have some kind of side effects, that is like a knee pain or operating pain or something after taking the second dose of vaccine. Yes, these vaccines were taken under the permission of emergency permission, if I have to recollect it back, in 2021 and early 2022. So these vaccines are undertaken the clinical trials. No, it is not that they have not taken clinical trials. They have undergone the clinical trials. And if you see the efficacy of these vaccines are efficacious. They have the 90% efficacy. But the thing is, since they have taken the emergency approval, and most of the trials have been completed at the earliest, means at the faster rate than the usual the viral vaccines. So, for example, the dengue vaccine, you have not seen the dengue vaccine in the market presently, even we have the outbreaks of dengue, because we have not seen a pandemic of dengue. So we have to say that word. So in the same way, it is not that it came at the faster rate. Now the technologies we have is a reverse vaccine technology, that is known as reverse vaccine technology, by which we can able to manufacture the vaccines at the faster rate than the previous technologies. Coming to the mutations, you have asked how these are going to affect vaccines. Yes, after you vaccinate the population at the larger scale or at this proportion, then the virus, which is the RNA virus, and it is as you know, this is a virus which is not having the proofreading function. So what will happen is, if the virus is not having the proofreading function, it will have the both ways. It can be lethal to the virus itself, or it can be a lethal to the human host also. Means it can take a mutation which can lead to the highly pathogenic virus, and it can lead to a mutation which can perishes the coronavirus completely also. So it happens for the virus which is not having a proofreading function. So these RNA viruses are more prone for mutations. And as these mutations are going to be maybe originated by these vaccines, as well as the number of people have been affected. As I told to you, one is mutations arises due to the viruses once infect an immunocompromised or immunocompetent host. And viruses also undergoes mutations once they compete with another virus which inside the host, and the host is responding to it. For example, in the when we are in the pandemic, we are started giving the vaccination itself. So the virus is is also undergoing the mutations, seeing this vaccination, and we are also giving the vaccination to the population at the faster rate. So we obviously we encounter more mutations and more variants at the time compared to the ones when we have already vaccinated the most of the people. Now we have the new mutation, and till now whatever the mutations we have seen, they are all going to be more lesser pathogenic than the Delta variant, which we have seen the highly pathogenic and highly virulent strain.
Thank you, Dr. Ravi. Thank you for the nice information, the vast information about coronaviruses.
Thank you. Thanks a lot.
Do we have further questions for Dr. Ravi? Okay, so thank you, Dr. Ravi. We hope like if you want to stay with us, you can. I know you must be busy with a lot of work, so you can proceed with that too. It's your choice, but we will be happy to if you will decide to stay with us. But moving ahead.
Thank you very much. Thanks a lot.
Thank you, Dr. Ravi. Moving ahead with our next speaker, and she is Dr. Vijaya, Dr. Rekha Vijayvargiya, and Dr. Rekha is the professor and head of Department of Botany, University of Rajasthan, Jaipur, and she works on the pharmacological properties of plants, and her topic is Towards the Hunt of Noble Pharmacological Properties of Plants. And let me check with Dr. Vijaya if she is available.
Yeah. ठीक है, तुम चले जाओ अभी, ठीक है, you come back tomorrow morning. अभी क्या है यार, shipment further connected, blue dot.
Dr. Ravi?
आगे
सर अभी ये मुझे मेरी
Dr. Ravi?
जयपुर में आपको पूछा है, जयपुर से मंडी जयपुर में है, शिपमेंट 5 दिसंबर।
Dr. Ravi?
Dr. Ravi? Maybe Pranavji, you can mute him from your side.
Okay. I thought you have a question for.
No.
from-
I was just trying to tell him that he
Okay.
is
Right.
unmute and.
Yeah, he muted himself. Right.
Okay, fine.
Let us wait for some time. Dr. Rekha, she is the head of the department, must be busy with official work. So also her time is 11 a.m. So might be she will join by that time. In the meantime, we can grab some coffee or tea and stay here, and we can talk.
Take care that you are not taking extra aluminum.
Yes, definitely. Because whatsoever we have talked about in this conference and beyond, we need to take care of that. We need to consider it in our daily lifestyle. Otherwise, there is no use of doing these conferences. So anybody else want to talk? I want students to talk. I hope we should wait for Dr. Rekha. Thank you. Welcome back from the tea session. Dr. Rekha had just joined, and I would like to invite Dr. Rekha to start her presentation on towards the hunt of novel pharmacological properties of plants. But before she starts, I would like to say I want to introduce Dr. Rekha to you all. Dr. Rekha Vijayvargiya is the head of Department of Botany, University of Rajasthan. It is in Jaipur, and her research interest is in screening, identification, characterization of bioactive compounds from ethnomedicinal plants, the assessment of bioactive compounds for various therapeutic purposes, and human disease management. She's also her lab is basically work upon the plant pathology and biochemistry. She has attended several conferences and had chaired the sessions in those. She has more than 70 publications and 2 books, and she had supervised more than 15 students. Without wasting much time, over to you, Dr. Rekha.
You hear my voice?
Yes, yes, Professor Rekha.
Okay, okay. Now I share my screen with my PowerPoint presentation. Got it or not? Are you got
Not
it?
yet. Not yet.
Not yet. Oh, okay. My screen is not shown.
No, ma'am, not yet. We cannot see your screen.
Okay, I will try my best. Now?
No, ma'am.
Still not?
No, ma'am, we cannot find your screen.
Okay.
Ma'am, if may I help you?
Yeah.
I think there is one share screen button at the below. When you click over there, in the bottom panel, when you click on share screen, it will ask you to select the screen through which you want to share. So you will have to click that.
Okay.
And as you Yes, then
Already
there is a
clicked?
share button. Then there is a share button. When you select that screen which you
Yeah, yeah.
want to present, there
Okay,
is a
okay.
share button. You will have to click on the share.
Okay, okay. Okay, I will try.
Sure, ma'am.
There is something. Something going. Yeah, there is no option actually. Mm.
Madam,
Yeah, yeah.
I'm Dr. Nayak. I would like to help you. Like, in case you have already opened your slides.
Yeah.
Okay, then go to slide share in the share screen in Zoom.
Okay. 1 second.
Your video is coming. You have to click for the share screen.
Yeah, I tried, but it doesn't.
Now,
go.
after you get the share screen,
Hmm.
then
Yeah.
you use the Alt tab.
Okay.
Alt.
Alt tab. Okay, okay, okay.
Then you see so many screens available in your.
Okay.
You choose the full screen mode.
Okay, okay.
It's still it is not working. It's still your video only. It's coming. Not your screen is not shared yet.
Yet?
No, not your screen is not shared.
Okay, I tap it, but it doesn't working actually. Share screen.
You have share with share screen. You are not getting any option.
No.
Okay. Once you sign out, and then log in again and try the share screen.
Okay, okay.
Hello, Pranabji.
Yes, sir.
I think madam is having some issue. You can talk to her over phone.
I asked ma'am, Dr. Sarojji to send her presentation so that we
Yeah,
can work with it.
exactly. That will be a good option.
Yes, yes.
Okay, okay. I think she is having some issue with signing in also.
Yes, yes. Let me check with it. Yes, I hope it is visible to everyone.
Yeah.
Yes.
It is visible to everyone. Good morning, and thank you for favoring me for this. This is my topic towards the hunt of novel pharmacological properties of plant. Next. We have, excuse me, hello. This is about introduction about phytochemicals and sources and importance of phytochemicals. And in last, a glimpses of research results from my lab. Then next. The phytochemicals is a term that refers to a variety of plant-derived compounds with therapeutic activities, and they have many activities like anti-mutagenic, anti-carcinogenic, antioxidative, anti-inflammatory, etc. Next. The phytochemicals or plant chemicals are bioactive non-nutrient plant compounds that provide a range of activities from inhibiting cancer cell proliferation to protecting against oxidative damage that prevent cardiovascular disease and multiple cancers. For example, lycopene. This is a very important compound found in tomatoes. It is when we cook tomato, it has a very good antioxidant properties. Other than that, some phytochemicals like beta carotene, beta cryptoxanthin have been also linked to obesity prevention. So there are so many phytochemicals which are useful for human health. Next. Next. Then this is a classification of plant secondary metabolites. These are there are some nitrogenous compounds, some phenolic compounds, glycosides, tannins, and terpene compounds. In nitrogenous compounds includes alkaloids, non-protein amino acids, cyanogenic glycosides, and phenolic compounds include flavonoids, anthocyanins, flavonols, and glycosides. Other than that, there is glycosides, tannins like in tea, etc., and some terpene compounds which are very useful for human health. They are called plant secondary metabolites. Next. This is a chart which showing that there is the source of plant secondary metabolites and how we improve their enhance in plant secondary metabolites by using biotic elicitors and abiotic elicitors. However, the plants always, when grow in stress conditions, they have more produce more secondary metabolites, and so many metabolites are produced at so many plants or fruits or even leaf and pulses. They have different type of secondary metabolites which are very useful for us. For example, flavonoids, polyphenols, isoflavonoids, physiolane. There is a most important example of vincristine, which is anti-cancer, showing anti-cancerous activities, present in Catharanthus roseus, and myrcene and beta-carotene, limonene present in citrus fruits, apinine present in ginger, and etc. And there is cinnamon is also a very important, having very important secondary metabolites, and we also we can enhance them by some biotic elicitors like fungi, PGPR, plant hormones, carbohydrates, etc. And by giving them some good type of biotic factor, using abiotic factors like temperature, light, salinity, this is we can enhance the secondary metabolites from them. So this is the chart showing how we enhance the secondary metabolites, plant secondary metabolites, and sources of secondary metabolites. Then next. This is plant sterols. They are the very important components found in plants. This is plant sterols are known as phytosterols, constitute mainly beta cytosterol. However, they differ from human sterols like cholesterol. They are poorly absorbed by humans and in the process appear to block the absorption of dietary cholesterol as well, and thus help reduce blood LDL cholesterol level. Next. Initial research studies have been found that experimental doses of plant sterols can be effective in countering the effect of testosterone-mediated hypertrophy in prostate glands. Again, they help minimize the risk of blood pressure and prostate cancer in men. Their effect in women, however, are found to be neutral or some beneficial effects on breast, uterine, ovarian receptors. Next. Then there are some other types of phytosterols. They are also very important, like campestrol, beta cytosterol, gamma cytosterol, tocopherols, that is also known as vitamin E. Campestrol is found in buckwheat. Beta cytosterol is found in avocado, rice bran, corn oil, fennel, peanuts, soya bean, basil, etc. And gamma cytosterol is also found in buckwheat. And vitamin E, there is so many sources of vitamin E like almond and etc. So these are the very important phytosterols which are very important for our health, and they are using as phytochemicals or in allopathic, even in herbal Ayurveda and herbal medicines. Next. Then there are some other sterols. They are found in plant, that is omega-3, 6, 9 fatty acids, dark green leafy vegetables, grains, legumes, nuts, and gamma linoleic acid. This is found in primrose and blackcurrant. Next. Then there are some terpenoids which are also very important. They are referred to as isoprenoid and naturally occurring chemicals found in all types of living things. Plant terpenoids are known for their aromatic qualities, contributing the scent of eucalyptus and the very pungent flavor of cinnamon, cloves, mint, and ginger. And they are also working as anti-inflammatory and antioxidative properties. Next. Then monoterpenes are also important for monoterpenes are also showing very good antioxidant activities like limonene. They are oil of citrus, cherries, spearmint, garlic, celery, maize, etc. And there is parallel alcohol. This is found in citrus oil and caraway and mints. They are very they have also a very good health benefits. Their fragrance is very good and they are very helpful for our health. Some health properties, they are showing some health properties, good health properties. Next. Then carotenoids have been shown to reduce the risk of certain types of cancer that is present in carrot and that is sweet potato and garlic, and these are very important for prostate, cervical and digestive tract and lung cancers, and some breast cancer, cervical and prostate cancers. They reduce the risk of certain type of cancer. If we are using them, this is very important of showing very important activities, biological activities. Then next. Alpha carotene in carrot, it is present in carrot, pumpkin, maize, orange, etc. And beta carotene, it is present in dark leafy greens and red, orange, yellow fruits and vegetables. And watermelon, guava, lycopene is present in guava, watermelon, apricot, carrot, autumn, etc. Then phytoflune and phytoene present in sweet potato, orange, phytoflune is present in star fruit, sweet potato, etc. These are all sources of beta carotene, carotenoids, they are also very important phytochemicals. Then next. Xanthophylls. They are also classed as carotenoids, and some of the fruits like mango, tangerine, orange, papaya, peaches, and grapefruit, kiwi, etc., and spinach, turnip, maize, red pepper, pumpkin, oranges. These having all very good amount of xanthophylls, that is cryptoxanthin, canthaxanthin, and zeaxanthin. Next. Other health benefits attributed to astaxanthin, lutein, and riboflavin. These are also present in some important fruits and veggies, like astaxanthin is present in microalgae, yeast, and salmon, lobster, and some crabs. And lutein is also present in spinach, turnip greens, red pepper, pumpkin, mango, papaya, orange, peaches, sweet potato, honeydew, melon, etc. But the amount of these phytochemicals are differ in every and each veggies and fruits. So we can, if we are using them, so it doesn't matter it is beneficial as we are using it. Some potato or mango. So this is not the way to. First of all, we extract them. Then if we use that in that way, then it is useful for health benefit. Otherwise, these are all having health benefits, but now on that way, on medicinal way. Next. This is another carotenoids, including protection against health. This is that is heart disease, cataracts, and improvement in blood sugar regulation and protection of nerve cells, and which may help prevent or reduce the severity of Alzheimer's disease. These are all about carotenoids. The next, then phenolic acids. Phenolic acids, they are also another important phytochemical. Includes salicylic acid, vanillin, gallic acid, allergic acid, tannic acid. These are all, the source of these acids are peppermint, peanut, vanilla beans, tea, mango, strawberries, walnuts, strawberries, and guava, grapes, and tea, etc. Next. Out of them, the allergic acid is found in a number of berries and other foods, especially strawberries, raspberries, and pomegranates. They may protect the cancer against several different ways. It may cause apoptosis of cancer cells, and it may help the liver neutralize cancer causing chemicals in our food, or phytochemicals present in our food. Next. This is tannic acid. This is all you know that it is present in tea leaves and coffee. So these tannic acid is important to treat cold sore and fever blisters, and mouthwash and gargles for sore throat, sore tonsils, spongy or receding gums, and skin rashes. Tannic acid is also taken by mouth dysentery, bloody urine, painful joints, and even persistent cough. Next. Curcuminoids. This is another important phytochemical that it is also includes in natural phenols that are responsible for the yellow color of turmeric, and this is the agent responsible for the most of the biological activity of turmeric. It has shown a very good antioxidant, anti-inflammatory, and anti-cancerous activity. It may reduce iron absorption. Next. Then preliminary research has found that curcuminoid binds to amyloid proteins associated with Alzheimer's disease. Because curcumin increases fluorescent activity and after it binds to amyloid protein, curcumin is being studied as possible identifier. Tests have detected amyloid proteins in human eyes, offering the possibility that simple eye exam could provide early detection of the disease. Next. Then polyphenols, bioflavonoids, these are the other phytochemicals which are also very important. They are red, blue, purple pigments, and they may affect cell-to-cell signaling, receptor sensitivity, inflammatory enzyme activity, and gene regulation. Polyphenols showing very antioxidant ability is to scavenge free radicals and upregulate certain metal chelation reactions. And there is then anthocyanin. This is present in red wine, many red, purple, or blue fruits and vegetables. Pelargonidine, peonidine, cyanidine, and delphinidine these are the colored, very colored fruits. That is raspberry, strawberry, blueberry, cherries, red apple, pear, blackberry, cranberry, eggplant. These are the very purple color, not only red, purplish color fruits and veggies, and they have a very good antioxidant activity, showing very good antioxidant activity. Next. Then flavonols. These are another type of phytochemicals. Flavonols, important one is quercetin, gingerol, and camphorol. They have showing very good antioxidant property as well as anti-inflammatory effect. Quercetin is present in red and yellow onion, tea, wine, apples, cranberry, etc. And gingerol is present in ginger. And camphorol is present in tea, strawberry, gooseberries, cranberries, fruits, apples, peas, spinach, and tomatoes, broccoli, cabbage, and all these fruits and veggies have camphorol, and this is very good antioxidant. Next. Then myricetin is also a flavanol, and fistine and rutin, isothamine. These all are flavonols. They are present in grape, red wine, strawberry, cucumber, citrus fruits. Rutin is present in citrus fruit, tomatoes, peaches, apricot, asparagus, parsley, etc. And isoremtine is present in red turnip, goldenrod, and mustard leaf, and ginkgo biloba also. Next. Quercetin is also it is showing another property also inhibit the oxidation of low density lipoprotein, and it is LDL is the bad cholesterol that linked to an increased risk for heart disease. This is commonly known, and this appears to offer protection against cardiovascular diseases. The quercetin is an important phytochemical that by this cardiovascular, we can reduce the cardiovascular disease. Then preliminary research suggests that quercetin exerts inhibitory effects on various types of cancer, and it may also have antiviral action. Next. And quercetin is also best known use in the treatment of seasonal allergies because of its antihistamine effect. And it is also has been found to improve the quality of men suffering from chronic non-bacterial prostate inflammation of the prostate gland that is often painful. And this is quercetin is a very good and important phytochemical that can reduce the inflammation of prostate gland. And it is also used in allergies. And this is the chart showing how colored fruits and veggies are important. How can we should use these colored fruits and veggies so that These because these fruits and veggies have antioxidant properties, anti-cancerous properties, anti-allergic properties, and having vitamin C and vitamin E, all that, all the vitamins. So this is red color is present in cherries and pomegranate and tomatoes, and yellow color is present in the yellow fruits are oranges, carrot, and reddish and yellow is carrot and oranges, and then lemon, and green veggies are cabbage, kiwi, and some beans. They are green in color. All veggies are green. Most of the veggies are green in color, and the purple is eggplant, blackberry, grapes. They are purple in color. They are also they are very good antioxidant. And then white, that is white cabbage and reddish, and garlic, onion. These are the white in color, and this is the core of phytochemicals present in veggies and fruits, which we have to use them accordingly, so that our health is we can keep our health good. Then next, then stilbenoids. These are some terpenoids, and these are present in grapes, blueberries, grape skin and seeds, wine, nuts. These are very important stilbenoids. Next. And resveratrol is found in grapes, purple grape juice, red wine. This is a very good antioxidant, having uh, antioxidant property and anti-inflammatory property, and it may help extend people's lifespan and reduce the risk of heart disease. Next. Then this glycosinolates and isothiocyanates. These having sulfur containing glycosinolates are found in cruciferous vegetables, and that is present in cabbage, broccoli, scallop, Brussels sprouts, etc. So these are very important. Then isothiocyanates in foods like scallop and collard greens and watercress help the growth of breast cancer. They are important in breast cancer, inhibit the progression of lung cancer, and cut the risk of colon and prostate cancer. This isothiocyanate and phytonutrients also prevent toxins from damaging our DNA. So that they are also very important phytochemicals. Next. Capsaicin. You all know about the capsicum, which is having capsaicin. Capsaicin is an active component of chili peppers. The highest concentration of capsaicin can be found in the white pith of the inner wall, where the seeds are attached. Capsaicin is used as an analgesic in tropical ointments, nasal spray, and dermal patches. It may be applied for the temporary relief of minor acne and pain of muscles and joints associated with arthritis, backache, strains, and sprains. So this is the very important phytochemicals. And the capsaicin cream are used to treat psoriasis as an effective way to reduce itching and inflammation. It selectively binds to a protein known as TRPV1 that resides on the membranes of pain and heat sensing neurons. Capsaicin may be used to help regulate blood sugar level by affecting carbohydrate breakdown after a meal. It also increases satiety and reduces the energy as well as fat intake. Sorry. Then these are the glimpses of research from our lab. We have some isolate and characterize the bioactive compounds of Melotheria, Meda serpentana, and Trichosanthus cocomeria. Next. These are some slides showing antimicrobial activity of pet ether extract of Madagascar M. Meda serpentana against selected microbial species like E. coli and Asorius. This is leaf extract, stem extract, fruit extract, and control. And this is again some microbial against selected microbial species, Meda serpentana, showing activity against selected microbial species, that is E. coli and Asorius. L for leaf extract, and S for stem extract, and F for fruit extract, and the C for control. They are showing a very good activity against E. coli and Asorius. Then again, there is an antimicrobial activity of methanolic extract of M. Meda serpentana against selected microorganisms. That is again some microorganisms, and leaf extract, stem extract, and fruit extracts were taken, and control is using. And these slides showing the activities, how much activities they are showing in these petroplates. Then we are calculate them by some formulas. And antimicrobial activity of extract of T. curcumariana, that is against selected microorganism, that is against, this is the petroleum ether extract, and below that the ethyl acetate extract of leaf extract, stem, and fruit. So these are they are showing against P. These are the four microorganisms we are taking: S. aureus, E. coli, P. aeruginosa, and B. subtilis. Bacillus subtilis, and Pneumonia aeruginosa, and E. coli, and S. aureus, Staphylococcus aureus. And these are again methanolic extract. This is methanolic extract of some bacterial and fungal species. Showing antimicrobial activity of leaf extract, stem extract, and fruit extract, and then control. We are using control as some antibiotic for bacteria and fungus for fungal strain. So this is all about how we can isolate and identify. First, we identify the phytochemicals, then we are using them against some for microbes, so that how much they're showing microbial activity, then we calculate them, then these are the results. Thank you so much.
Thank you, Professor Rekha. Thank you for the information of phytochemicals which are beneficial for our health. We do not have much time for questions, sorry. So the student can write to her, or you can ask your question in chat. We will share with Professor Rekha later on. So moving ahead with our next. Thank you, Professor Rekha.
Thank you so much.
So moving ahead with our next speaker, but before that, I would like to ask Dr. Ritesh Shukla sir to introduce the speaker.
Good morning, Dr. Ritesh.
Okay, good morning. Good morning. Yes, good morning. Very good morning to one and all present in the conference. It gives me immense pleasure to invite and introduce our next speaker, Dr. Akhilesh Kumar Verma. He is at present assistant professor in the Department of Zoology in Cotton University, Assam, since 2016. Regarding his education, he has done his MSc Life Science from Dibrugarh University, Assam in 2007, and then proceeded for his PhD from NEHU, Shillong in the year 2012. He has also been a Deputy Research Associate at Chachar Cancer Hospital and Research Center, Shillong in the year 2013 and 14. He has also done his postdoctoral degree from Morehouse School of Medicine, Atlanta, USA in the year 2015. His current research is on the pearl culture, although he is a man of molecular biology, and he has done a lot of work in phytochemicals, mediating the anti-cancer activity and pathway analysis of it. He has a number of awards and honors in his name. Indian Science Congress Association has awarded him Young Scientist Award in the year 2013. And later, in the year 2020, he has been given the Best Research Publication Award, as known as Governor Excellent Award for the year 2020. He has got 2 Talent Search Contest Award as well, given by the Guwahati Biotech Park as a startup Assam and Science and Technology Department, Government of Assam, in the year 2019, and as well as in the year 2021, for the development of innovative method for nucleus design and implantation in the pearl oyster, followed by the community mobilization and sensitization for freshwater pearl culture, leading to entrepreneurship development. This is not the end. List is very long, and he has also been he has received the highest citation award in the year 2021 by Royal Society of Chemistry, and he has also received Meritorious Fellowship Award in the science in the year 2009. And if we continue, more and more awards have been there along with him. And it gives me again immense pleasure to introduce him and now invite him for enlightening us on a very innovative technique. And this is known as freshwater pearl culture. And he has done a lot of work, and I also have been awarded with innovative awards in talent search. And I now hand it over dealing with to you, Dr. Akhilesh, and he will enlighten us in this topic, freshwater pearl culture and the surgical procedures. Now,
okay, thank you. Thank you, Dr. Ritesh, for introducing me. And thank you very much for letting me to be a part of this mega event. Yes. So thank you to you and all your team. Yes. So now I'm going to share my slide.
Yes, please.
Is it visible, Dr. Ritesh?
Yes, sir. It is visible.
Okay. Okay. So, dear participants, so I'll be talking about freshwater pearl culture and surgical procedure. So, if you find any difficulty in between, you are free to interrupt, and then we'll discuss about all those things. So, very first, you should know what is pearl. So in nature, what happens? A pearl is formed when foreign particles or any piece of sand, insect or parasite that enters into the body of mussels and they cannot comes out. Then what happened? The animal used to coat that particular materials, and that leads to formation of pearl. And this is not the only region. Many a time what happened, the damage in the mental tissue of the animal is going to produce pearl. So there are multiple regions how pearls are formed. So the natural process of pearl formation has been utilized by scientists for farming purposes. So what happened? Anybody, those who are interested in pearl farming, they can do at their own land. Even in aquarium, it is possible. So Mikimoto Kokichi, Japanese scientist who is known as father of pearl, and the first pearl that was produced in around 500 AD is by China, where they produce Buddha blister pearls. And then in 1899, Japan is credited for production of industrial gem. And finally in India, around 1981, Central Marine Fishery Research Institute, who commercially produce a culture pearl. So these are a very brief history about the pearl culture. So these are the three different species that are most commonly used for pearl farming, and it is present all over India and even in Northeast, different state of Northeast. All these three species are available. The first one is Lemilodens marginalis, second one is Peresia corrugata, and third one is Lemilodens corianus. So by seeing the outer cell color, you are going to differentiate. And moreover, there are certain key on that basis, species can be very well identified. Next is major cultured pearl types. So what could be the different types of pearl? So it may be of round type or designer pearl, which is a very recent technology that leads to a formation of a designer pearl. So any design can be transformed into pearl. And then finally we have a rice pearl. So why it is known as rice? Because the shape is irregular, smaller as compared to round and designer pearl, and it has lots of pharmaceutical value. You might have heard about moti bhasma in Ayurveda. So that moti bhasma is prepared from the rice pearl. And other two, round pearl and designer pearl, it has a jewelry value as well as decoration purpose people are using. Okay, so types of nucleus. So one thing I would like it to make it clear here, the term nucleus in pearl culture indicate any foreign materials that is inserted into the animal for production of pearl. So that could be of different type. If you want to develop round pearl, then round materials you need to insert into the animal body. If you want to develop designer pearl, then you need to implant designer nucleus. And then next one is MOP nucleus, mother of pearl. So what happened? The mother of pearl area of cell is cut into multiple shapes, and then that shape is introduced into the animal body for pearl production. And the last one is mantle tissue nucleus. That means a tissue of donor animal is cut into multiple part, maybe a variable size, and then it is introduced into another animal. And then a pearl is formed. So that pearl is derived from the mantle tissue. That is why the name is mantle tissue nucleus. Okay, so how round and designer pearl nucleus is produced? It is produced by making powder of dead animal cells, which is shown in diagram here. You can see diagram I have shown. Then the next one is MOP nucleus. So what happened? The shining part of cell is cut into different shapes, and that can be used for production of pearl. It is known as MOP nucleus. And the last one is mantle tissue nucleus. So what happened? Here I have shown light red color area. From that area, the mantle tissue can be isolated, and then it can be implanted into the new animal, and that may lead to production of rice pearl. So these are the four different types of nucleus and their source of production. Next is factors affecting pearl culture. Means what are the factors that may mediate pearl culture? So number one is temperature. So the optimum temperature for pearl farming is 25 to 30 degrees Celsius. And then bottom of the water body, it should be gravelly bottoms. Small size pebbles and sand-like materials is preferred. Muddy bottoms should be avoided. So if there is more than 1 feet of mud, then it is not recommended for pearl farming. Then silt load. Silt load, it is preferred to have a clear water without any turbidity. Salinity range is given 25 to 38 ppt parts per trillion. And then depth, it should be minimum 1 meter depth from the top surface of water body. And then primary productivity. The water body where anybody is willing to go for pearl farming, it should be rich in phytoplanktons and zooplanktons. Why? Because these are the two major food source of this animal. So if you provide better quality of phytoplanktons and zooplanktons, then you can expect a good quality of pearl. So these are the factors very much essential while going in the field of pearl farming. Next is why anyone should focus about pearl farming. So here I have shown different items that is been imported from outside. The first one is petroleum product, which market is around $155 billion. So coming to the fourth point, here you see, for pearls, it is $31 billion market. I mean, this much amount is invested for procurement of pearl from other sources. And let me tell you, if we consider 100% global production, our country doesn't exist or come into the range of even 1%. So now you can think about 99% we are dependent from other countries for pearl. So by seeing this data, I think there is a lot of scope in this field. Next is about the biology of pearl mussels. So what happened? The animal belongs to phylum Mollusca, and it is comes under class Bivalvia, the pearl mussels, oyster clams. And this is the general morphology of the animal mussels. It is consist of two valves, right and left, and then umbo. Umbo is the top corner area. It is the first part which is formed during the development. And then growth line is shown. So here you can see a prominent line on the surface of animal. This is known as growth line. And every year one growth line is formed. So this can be used for determination of age of the animals. Suppose any animal possesses 5 growth line, that means you can say roughly it is 5 years old. Then coming to the other part, the blunt area is known as anterior part. It is broad, and the pointed and little comparatively narrowing part as compared to anterior, you are going to see posterior, this one. And then upper side is dorsal, down is ventral. And as I said, umbo is the first part, and then down you see animal used to walk through the foot. So you can see the cell, from the cell it is protruded out. And then towards posterior part, here you can see there is two canal, incurrent canal and excurrent canal. So through incurrent canals, what happened? It receive water. So any food materials or oxygen that comes along with water, that is trapped inside the body, and the remaining water is removed from excurrent siphon, or you can say canal. So this is a general physiological process. Okay, so next, there are 3 main parts of the animal. The first one is muscular foot. So here you can see it is shown, foot area, blackish part. And then visceral mass containing digestive, respiratory, circulatory, and reproductive part. So these are all visceral mass from both sides, visceral mass. And then the very important part is mental. So what happened? Down photograph, you can see the area which is very uniformly distributed central area is known as mantle tissue or mantle tissue layer. And again, here you can see two prominent pink color tissue. It is known as abductor muscle. So what it does, it holds two cells together so that it cannot be opened very easily. Next is internal anatomy of the animal. As I said, it possesses one excurrent canal and incurrent. So incurrent is always bears fine thread-like structure, and excurrent is smooth. You can see in the photograph. Okay, so what happened generally 8 to 12 centimeter length of animal is used for pearl farming. So these are the parameters I have shown through this images, how you can measure the length, width and height. So this is very important features that you should keep in mind. Average size is 8 to 12 centimeter. Okay, so food and feeding habits. So this animal prefers phytoplanktons and zooplankton. So what happened, if you provide very good quality of phytoplanktons and zooplanktons, then the pearl production is like very good. And why animal prefer plankton for pearl production? Because it is a very rich source of nitrogen. So nitrogen rich as well as phosphorus rich foods are recommended while doing pearl farming for the animal. And life cycle is very interesting. So what happened, the male produces sperm that goes inside the body of female body, and then after some times female body produce a very small larva known as glochidia larva. And then this glochidia larva attached on the scales or maybe gills of the fish. So fish is very, very essential for completing the entire life cycle of these mammals. So what happened, this glochidia, it attached to the fish fins, maybe gills or scales, and spent some times, maybe 2 to 3 months. After that, it detached from the fish body and then independent development takes place. So this is the whole process of life cycle of freshwater mussels. So here you can see how the glochidia looks like. You see the structure. And it also poses a sucker kind of things that help in attachment with the gills or maybe with the scales. So here I have shown how the glochidia is attached with the fins or gills of the fish. So this photograph is taken with the help of light microscope as well as transmission electron microscope. Okay, then how to differentiate between live and dead animals? So what happens in case of live animal, the cells are very tightly closed. And in case of dead animal, cells are open. So the moment you touch animal, if it close its cells, that means it is going to be like live. And if animal cannot close the cell, that means it is dead. So during pearl farming, you need to remove dead animal. Otherwise, because of their degraded or damaged tissue, infection may take place. And what is the reason for opening up this cell? It is because what happened, these abductor muscles get relaxed. The moment this abductor muscle get relaxed, the cell is open. Okay, next one is freshwater pearl culture technology. So mainly we'll discuss about the minor details that may lead to the surgery as well as some surgical tools as well as very good quality of food production for the animal. So what happened, from this animal, multiple products can be developed. So here I have divided into primary product and secondary products. So now if animal is live, then mainly primary product is formed that may include round pearl, designer pearl, or maybe rice pearl or some other kind of pearl. But after the death of animal, again, it is not useless. Secondary product can be developed. So what are those? Handicrafts items may be prepared from the dead cell, or it may be designer nuclei can also be produced. Then soft tissue of the animal is used for amino acid fertilizer production. And then finally, the outer cell is cleaned, washed, and then it is powdered, and calcium powder is produced that has got lots of agricultural value. So nothing is wasted in this particular muscles. So everything can be utilized during the whole process of your farming. Okay, so next we are going to discuss about mechanism of pearl formation. So chemically what happened? The pearl is about 82 to 86% aragonite crystals, which is made up of calcium carbonate. And then 10 to 14% it is organic matrix made up of conchiolin, a very special kind of protein. And then 2 to 4% is water. So these are the three major components of any pearls. The ratio may vary, but these are the major components. Okay, so what happened? When a foreign body or any kind of irritants enters into the animal body, then the epithelial cell get activated and it try to cover the whole foreign materials. The moment it covers, it detaches from the main epithelial layer and pearl is formed, as I have shown in the diagram. And the same concept we are teaching in our undergraduate student as well as postgraduate during our regular zoology course. But what happens if you go further detail, then you will find that if the inserted material is positively charged, which is very, very essential for pearl formation, then what happened? Am I audible now? Hello, Dr.
Yes.
Ritesh. Or
Yes,
anybody?
yes, you're audible. You're audible.
Hello, Dr. Ritesh.
Yes, yes, you're now audible.
Okay, okay. So, sir, can you
You're
see my
unable to see your
PowerPoint?
screen.
Can you see my PowerPoint?
Not yet.
Okay. Now, sir.
No, your screen is not visible.
I don't know what happened.
Pranav, are you there?
Yes, sir. I'm here.
Then if he has shared the screen, then you can present from your side.
So I'm going to reconnect again.
Okay, you
Is it
reconnect.
fine?
Yes,
Yes.
please.
Okay, reconnect.
Yeah. That will be better.
Sir, can you see slide?
Yeah, now it is visible. Dr.
Okay,
Klesh, it is
thank you.
visible. You can carry
Thank
on.
you.
Yes.
So I was talking about the mechanism of this pearl formation. So what happened? A multiple layer of calcium carbonate aragonite crystal is deposited one after another with conchiolin protein fiber. So conchiolin is a protein that form organic layer. So layer after layer, what happened? Calcium carbonate and this conchiolin form final product, that is pearl. So next is how to differentiate between natural and artificial pearl. So natural pearl formation takes place without human intervention. So naturally developed, no surgery is required, no any other kind of management required. Whereas culture pearls are also natural pearls. Only difference is human intervention in the form of surgical implantation of graft and nucleus is required. Whereas artificial pearls are fully synthetic. So what happened? Plastic coated pearls are also available in the market, or maybe some other kind of painted materials is available that are comes under artificial pearls. So next is, this is the very new concept. So conch are used for pearl production and the pearl quality is very, very high with multiple color. So mainly the mantle tissue of this conch are used for production of pearl. It comes in different color, cell color. You can see orange, pink, white, and very brilliant and very interesting kind of things can be produced. I mean the color card. Color pearl is produced by using mantle tissue of multiple color. Sorry. Okay, so this pearl farming can be done in the pond system, or it may be a geomembrane, a river, biofloc system can be used, cemented tank, as well as aquarium. So these are the different water bodies where pearl farming is possible. Next is, there are different steps of pearl farming. The first step is collection of animals. So it is better to collect from your nearby water body. Then second one is pre-operative care. So during pre-operative care, what happens? You need to keep your animal for sometimes in your laboratory condition or maybe in your own water body. Then next one is implantation. So during implantation, you need to do a minor surgery and then you need to place your nucleus, maybe foreign materials. Then post-operative cares, what happened here? after surgery, animal is placed with antibiotic solution. It may vary from 1 week to 15 days. And then after post-operative care, you need to place your animal into the water body. That may be pond, lake, river. And then you need to culture for minimum 12 to 15 months. After that, you can go for harvesting your pearl. So it required 1 to 2 years of time for entire process of pearl formation. Okay, so how to prepare nucleus? I mean, the foreign materials that is inserted into the body of animal, how to prepare that? So this is again very important part of pearl farming. For that, what happened? Mussels dead cells are used. So first component is mussel cells. It is very well cleaned. And then next component is tiles, the one which is used at home. And then sandstones. Sandstones are very small pebbles that you may find in sand particles. So these are the three components that are used in the ratio of 10:1:1. And then what happened? All these three components are mixed together with one glue that is known as araldite. So the ratio is, suppose you are taking 10 gram of powder, then you need to add 1 ml of araldite glue. And then you need to make a dough. So at the end, I have shown everything you have to mix together, and a dough-like things you have to prepare. The next step is the dough you are prepared, that small amount will be taken and it will be placed on the mold, and mold should be pre-coated with any mineral oil. So these are the different dyes, molds that can be used for development of various design. Okay, so after putting this small amount of dough on the shape of mold, you need to invert the mold, keeping on the top layer of sellotape. So what you need to do, you have to spread sellotape on the table so that adhesive part is on the top. And on that surface, you have to place your mold and then press from the top. So what will happen? The design will attach on the your sellotape, and then you can easily take out your mold. That can be used for next level of this nucleus preparation. So this is the whole process of making designer nucleus. Next is how to prepare a round nucleus. For that, same dough can be used. You need to take a small quantity and then you have to rotate as per diagram shown here, and then finally you will have a round part, a round nucleus, not part. It is round nucleus, and once it is inserted into the body of animal, then only you are going to get a round part. So the whole process after making designer nucleus as well as round nucleus, you need to keep this for 24 hours for complete hardness of the material. It will dry and then you will have final finished nucleus. Okay, so egg cell powder can also be used for production of designer nucleus, and later this can be used in pearl farming. So steps are very simple. Take a egg cell, make into small pieces, then make a powder in our regular kitchen grinder, and then you need to use glue, and then finally using mold you can give multiple shapes. Recently what happened, these colorful abalone cells are cut into various shapes and it is used for pearl production. So what happened, this produce very brilliant multicolor pearl and it has very high market value. So remember, this is a abalone cell that can be cut into multiple shapes, and same shape can be inserted into the animal for pearl production. Next one is MOP nucleus, mother of pearl. So what happened, the inner cell of the animal is very shiny part. So that part can be very well cleaned and multiple shape can be developed from that area. And if you do that, it is known as MOP, mother of pearl nucleus. So you can see multiple shapes. So it produces very high quality of pearls. So if you compare with the designer nucleus with cell powder with the MOP nucleus, so you will find in case of MOP, the quality of pearl is very, very high. Okay, so in market, this low quality nucleus is also available. So you should not procure this for pearl farming. These are mainly used for decoration purpose. So what happened, farmer, those who are not they are not having much knowledge about this nucleus, they used to buy. So remember that this yellow color as well as this freshwater cells cut is used mainly for preparation of button, or it may be for decoration purpose, but it cannot be used in pearl farming, which is very, very different from the original MOP nucleus. Okay, so the entire process of pearl formation, if you see, sometimes what happens, the nucleus itself react with the tissue of the animal. That times what happened, a very poor quality of pearl is formed. So the whole process is something like take a designer nucleus, implant into the animal body. It takes 60 to 65 days for attachment. After attachments, what happened? The layer after layer, nacre secretion takes place and deposition takes place, and then you have a final pearl product. So that pearl is not much of better quality. So what happened, you may get black spots or ununiform kind of shapes, or maybe some other kind of like irregular patches. So to avoid all those things, what happened, recently people are coating nucleus with different chemicals, and this chemical prevent tissue reactivity. So once it is introduced into the animal body after minor surgery, then it will not react with the animal tissue, and then you may have a very good quality of pearl. So this is the mechanism that I have shown here, how silane and poly-L-lysine coating is done on the surface of nucleus just to reduce tissue reactivity. This is how a nucleus looks like after coating. Outer surface is connected with some functional groups that ultimately provide positive charge. And then here I have shown my own lab data. So what happened, if we use biomaterial coated nucleus, then the attachment time is reduced. So that leads to reduction of 2 to 3 months harvesting time. So suppose your pearl is getting matured at 15 months. If you are using a biomaterial coated nucleus, you may harvest 11 to 12 month time period. So ultimately you are going to save 2 to 3 months. At the same time, what happens, if anybody is using biomaterial coated or bio-coated nucleus, then survivability also increases. So the animal without bio-coated nucleus, it can survive up to say 45 to 50%, maybe 60. But after using these coated materials, it can go up to 90 to 95%. I mean survivability. So here I have shown a comparative images. Top row is showing without bio-coated nucleus. You can see the quality of pearl is not so good. But downside, you can see the pearl quality is very good because it was coated with biopolymer. Next is you need a good quality of algae, because algae is the main source of food. So you have to first develop mother culture, and from that mother culture you can multiply your algae solution so that you can feed whenever it is required. For surgery purpose, you need a very minor tools, maybe plier, spatula, pointed forceps, scissor, stopper, and brush is required. These are the very minor things. So for designer pearl implantation, you are going to open cell of the animal that will be maximum 0.8 mm. You cannot open more than this. If you open, the animal is going to die. So remember, the maximum you can open is 0.8 mm. Within that opening, you have to perform your surgery. And here, left hand side, I have shown the area pointed with arrow, which is showing mental tissue area. Next. So, where to place your nucleus? It may be designer nucleus or it may be of rice pearl nucleus. So, here I have shown the places where you can place your nucleus. And this will be in between cell and mental tissue, remember. Okay, so surgery step 1, you have to go through these figures. First, you need to hold your animal, then you need cell opener and a spatula. So at very first, you see number 3 steps. You need to insert a spatula from the center of the animal, and the moment it is inserted, you have to insert cell opener. And then this cell opener is having one clamp, so you can adjust 0.8 mm distance. After opening, you need to create a pocket. So pocket will be created in the mental tissue area. Let me show you here. You can see here, pocket is being created. So within this pocket area, you need to insert your nucleus. So in next figure, you see nucleus is being inserted. Then next, after putting nucleus in, you need to settle mental tissue, and then you close cell of animal, and then you can place in water body. So it is also recommended after surgery, you need to keep animal without water for 2 to 3 hours. So after surgery, you can keep your animal at room temperature without water. So whatever we have discussed so far, it is about designer pearl surgery. Next is gonadal implantation, and it is done for round pearl surgery. If anybody want round pearl, then they need to do a surgery which is little different from designer pearl. So for that, what happened? You need to kill one animal, and then mental tissue ribbon is taken out. So you can follow the diagram which is shown here. You have to take out ribbon from the animal, tissue ribbon, and then this mental tissue is cut into multiple pieces. The size may be 2 to 3 mm. And it is known as mental tissue graft. The next step is make incision in gonad. So this incision will be prepared in another living animal. Remember, the tissue you are collecting from the donor animal which is already killed. So tissue of donor animal will be introduced into the live animal. So this incision you will develop where? Inside the gonad, and then you have to place your nucleus. So what will be the order of placing nucleus? First, you will place a mental tissue graft, then you will place a round nucleus bead, and then third point again mental tissue graft. So 3 layer of this tissue is going to form. Not tissue. First layer will be your mental graft tissue. Second is round nucleus, and third one is again mental tissue graft. So this tissue graft will cover your nucleus from 2 sides, and it is very, very essential. Otherwise, the pearl formation will not take place. So here I have shown a red bulleted area. This is the area where you can introduce your round nucleus along with this mental tissue graft. Okay. So next surgery is about rice pearl surgery. So for that, again, you need to take out mental tissue ribbon, just like the previous one. Okay. And then you have to cut into multiple pieces. 1 to 3 mm will be the size. And the interesting point is what you see inside mental tissue, you have to make a hole, and within that hole, you have to put your graft. So actually what happened, mental tissue is made up of 2 layers, outer layer and inner layer. So in between outer and inner, you have to insert a needle. And the moment you will insert needle, a tube-like structure will develop. Within that tube, you have to place your nucleus. And after culturing this animal for 1 or maybe 1 to 2 years, you may find pearl like this. Then you have to take out mental tissue and you can get rice pearl. Okay. So after surgery, what you need to do, you need to place animal in any water body, maybe a pond. So this is the arrangement how you can place your animal. You need to put 2 poles. It may be made up of bamboo or iron or maybe any other materials. And then you need to tie a rope. And in between, I have shown here a square shape box. These are all net. Inside this net, you have to place your animals after surgery. So you will take a net where you will keep your animal. That will be finally connected with the main rope that is ultimately tied with the bamboo poles. And from the top, water top to the net, the distance should be 1 meter. So this is how you can place your animal after surgery for a rearing purpose. And this will be done for 1.5 years. This is the process. Here a net is shown and you can see how animals are placed inside. And then this is the photograph where a real animal is placed inside a water body. This is how it looks like. Okay, so let's discuss about capital cost detail. Suppose you are having 100 feet by 80 feet area where you can put 25,000 of muzzles. Total investment will come around 18 lakh and total return may be around 96 lakh. So net profit will be 77 lakh, which is around 4 to 5 times profit. And if anybody want to know market potential of this pearl, then let me tell you, pearl are of different grade. It may be of AAA grade, AA positive, AA or A grade. So AAA grade pearl that cost around 700 to 1000, AA plus 500 rupees. The cost is per pearl. Then AA grade 300 and A grade is having 200 rupees. And if it is golden or colored pearl, then the cost is very high. You see 2000 to 10,000 in case of AAA grade, AA grade positive, it will be 2000 rupees. And likewise, you can see the cost. So high quality pearl is really having high demand in market. So there are multiple cities in our country like Hyderabad, Rajasthan, Mumbai. There are open market for it. And farmer can also get connected with online stores where they can keep their own product, or they can also approach local jewelers for selling their product. So these are the secondary products that are formed by using sale of dead animals. Button can be prepared, multiple decorative items, earrings, hair clips that are available in the market. And these are all produced from the dead animal cells. And very interesting, this cell carving. So there are different kind of carve is done on the cells. And let me tell you, it is more costlier than the real pearl. So these are the mainly used for decoration purpose. Okay, so our long-term goal is community mobilization and sensitization for the freshwater pulp culture. So this is our long-term mission. So whatever I said, this is all about freshwater pulp culture, surgical process.
Yes, thank you, Dr. Akhilesh. It was a really very interesting and very vivid manner, in a very lucid manner, and in a very attractive, impressive manner. You presented the PPT and the entire concept of pearl culture.
Thank you,
and
sir.
Definitely, this is a very innovative idea.
Sir.
And during the lockdown period, I was also got interested in this particular thing. And
Yes, sir.
then I came to know about you. And
Okay.
that then I had made contact with you. And you are all the time helping me, because in our college also we are initiating such type of activity. And definitely, again, it doesn't matter any time. At night, I'm mailing you and seeing the photographs and results, and you are replying at night, even in the morning. And really, this is a very interesting field. So as to even not only this, to attain the UN sustainable goal targets, with this particular thing, we can achieve a lot of targets of UN sustainable goal. Not
Very
only
true.
protecting the environment, Atlantic ecosystem, and then also economic value, and for the skill development. And what we talk about the global sustainable, I think so that can start from the village level. If you start from the village level, then go for the district and state and then nation, and then you can achieve the global sustainable development. And your university and your efforts doing a lot of work. I've seen you have also been organizing many workshops regarding this. And we are in our college just in the incubation period. We have started as a pilot project, and hopefully in the next year we will be doing the first harvest. And meanwhile, I will be again troubling you a lot for getting a lot of help and information from you. And
Sure, sir.
even the audience might have been also very much enlightened with this particular topic, and they may also even contact you for this. So Pranav, do you have any time to put up one or two questions, or you can mail Akhilesh later on, he can reply?
No, we can go with the questions. So
Okay.
I think this is one of the most interesting topic, because we only see that pearls are beautiful, pearls are this, but we don't know how beautiful its cultivation process is, and how wonderfully Dr. Verma has explained each and every aspect of pearl culture, freshwater pearl culture. So I would like people to ask questions, because this is really, I have been in touch with Dr. Ritesh sir on this. He used to talk to me about Dr. Akhilesh and also about the freshwater pearl culture. So I am in view of few concepts that you have shown over here, but I think most of the participants can ask you questions if they have queries.
Okay, I will be happy to answer.
So, sir, there is a message and question in the chat box. If you can take up one.
Okay.
Can I read it?
Okay,
for
okay.
the-
There is question from Dr. Jyoti Bhojwani. The question is about nitrogen is also very essential for pearl farming. Is it so that pearl farming can be done only underwater with phytoplanktons, or there is some other way? Nowadays, people are using in vitro technology. So what they are doing, the pearl producing cells are being cultured in the lab. And then by cell culture method, they are inserting nucleus, I mean the foreign materials, and then they are getting in the lab also. But the main thing is like, this is very much expensive process. If anybody want to develop in lab, they need to culture cells, they need to use culture media for long times, maybe 8 months, 10 months, and it will be very expensive. That is why people are going or exploring natural system like pond, river. But yes, it is possible in lab also to grow a pearl by in vitro technology. And from my side, I would like to tell to all the participants, like in Cotton University, we are organizing hands-on training that may be for 2 to 3 days. And all the time we keep 30% seat for farmers. We are not charging any money from them. So 30% participant is always farmer. They may be from anywhere, Northeast, outside Northeast, and the remaining will be like students or unemployed youth, startup, maybe faculty. For them, we are charging a nominal registration fee 500 to 1000. But for farmer, it is fully free. So they can also come, they can join, or they can also tell the person who is interested in this area.
Excuse me, sir.
So,
Dr.
yes,
Verma?
yes.
Actually, I am in UBA, that is the Unnat Bharat Abhiyan of the run by the central government. And in that we take up certain training programs in which we educate them about means how they can become self-dependent and start their own business.
Okay.
So in that, I would definitely like to invite you as a guest in our university in future. So do you provide guidance to them?
No issue. I will be honored. There is no issue, because our mission is to propagate the whole idea to the farmers and unemployed youth. And this is the main intention for my whole thing.
So, sir, I'll contact you regarding that. Once.
No issue. Dr. Ritesh can communicate with you.
Yeah, sure.
Yes, definitely you can do. And this was I had a talk with Pranav, and I told you that told Pranav that it will be a very interesting talk, and I will talk to Dr. Achilles, and you have accepted my invitation, and you in one phone call you accepted my invitation. I'm very thankful to you, because we know that knowledge sharing is knowledge squaring up.
Very true.
And yes, definitely, and you have rightly also said that in our also we are moving ahead with the motto that to incorporate in the syllabus, and then giving the opportunity to the students and provide them credit for an exemption system. Like they have to, once they are enrolled in the course, the opportunity will be given to the students to train a particular farmer. And when they train the particular farmer and the result is coming out of that, and they will be awarded marks for it. In future plan, we are in our college are discussing how to incorporate in the new education policy and everything. And definitely we will be again contacting you regarding this particular aspect.
Your idea is very, very interesting and encouraging, sir. Yeah. And just to tell you, sir, in very brief, recently we are targeting different drug rehabilitation center.
Yes.
So what we are doing, we are going to them, we are teaching them how to do pearl farming, because all rehab people, they are not thinking anything about their life. So we are somehow encouraging them to bring back into the normal life by doing this pearl farming, because it is like a very good business. They can make their life very happy if they use the whole things positive way. And we are providing all the training free of cost, even raw materials, other technical support. Yes.
Okay, I think once again, I thank you, Dr. Achilles. And over to you, Pranav.
Thank you, sir. Thank you, Dr. Akhilesh Sharma, for providing us such a wonderful insight into this unexplored area. And I think many of us would have started thinking to start startup with this idea that you have provided, because you have not only shown us the beautiful the beautiful formations of pearl and the surgery and everything else, but also you have shown the statistics where India lies in the commercialization of pearl, and so definitely it is having a huge scope Thank you for giving us these insights.
Thank you. Thank you, sir.
Students,
Dr.
yes,
Verma,
yes,
this is
Jayant.
Jayant. I have one small query with respect to the business perspective of this pearl culture. So you have mentioned that out of 100 by 10 or 100 something feet of pond, that investment is required around 18 lakhs, something around, right? Can you please go to that slide? Yes.
Can you see my slide?
Yeah, 100 by 80
Oh.
feet. So investment is around 18,000 to 30 lakhs, something around. So what all raw materials we require, and like how easily these are available in the market?
Okay, you see, we suggest for a farmer, if they are willing to go for commercial setup, then we always suggest them for natural system like river, pond, or maybe some other lake. But for those who are willing to develop concept, or those who are willing to have training on this field, they can go for testing all those things in aquarium or geomembrane system. So what happen in natural system, you don't need to bother about food of the animals, because in natural water body, phytoplanktons, zooplanktons, that grow naturally. But if you maintain in your home or aquarium or biofloc, you need to feed, and for that you need to have your separate setup for algae culture or phytoplankton, zooplankton culture. So that times what happen, cost increases. So generally pearl farming is considered as 4 to 5 times profitable business, but there are lots of other advancement like development of color pearl product. Say for example, if anybody develop black color pearl, so I can give you a very good example. Last year from our India, Dr. Ajay Kumar Sonkar, he got Padma Shri. Padma Shri for what? For developing a black color pearl. What was the size? 2.2 centimeter. So this was the world record. 2.2 centimeter black color pearl was produced by Ajay Kumar Sonkar sir, which is the world record. And the cost was around 30 lakh. You can think about 30 lakh single pearl, size 2.2 centimeter. So you can make it out, means how is the whole technology.
Right. And Dr. Verma, you have also mentioned about the grading system of this pearls, like AAA, AA plus, and all. So how these are assigned, and if there's any body that is regulating these?
Okay. You don't need to assign yourself. What you need to do, there are multiple pearl testing lab. Okay. So you have to take your own product, go to them, and they are going to assign based on certain parameters. So simply what happened, whenever we feel chest pain, we go for X-ray. So X-ray report comes with all the diagnosis, something like that. If you deposit your pearl to testing center, they are going to make profile of your pearl quality. That may be density, that may be luster quality, that may be thickness, everything. Multiple parameter is considered, and they are going to assign it is AAA or AA positive or A grade. So they will define.
Right, and they are also providing any certificate kind of fee, like in diamonds we have
Yes.
Okay.
They produce certificate, and with that you can go for commercial selling. Because the moment you will enter into market, the vendor will ask, produce me your certificate, pearl quality testing report. That time you need to produce.
Thank you so much. Thank you, Dr. Verma.
Yes, Dr. Akhilesh, that is coming under the gemology part.
Yes, GIS.
Yes. So I think so. We can now, Pravana, we can leave this. And thank you once again, Dr. Akhilesh, and later we'll have a talk regarding this later on.
Sure.
And,
Thank you, sir.
yes,
Namaskar.
Thank you, Dr. Verma. Thanks a lot for
Thank
this interesting topic. Thank you.
Thank you, team, for all the team of this mega event. Thank you.
Dr. Rashmi, can we proceed with our next speaker?
Yes, sure.
Please.
Dr. Tapan, are you there?
Yeah, I'm here.
Please share your presentation. So our next lecture is by Dr. Tapan Kanai. He is currently working as a macroscopic scientist in Frederick National Laboratory for Cancer Research as a part of National Institute of Health, USA. Before he moved to US, he was scientist in DRDO for more than 8 years. His primary research area is structural and biophysical studies of ApoBec3G nucleic acid complexes by X-ray and NMR, and structural analysis of other viral proteins such as hepatitis C virus and ribosome RNA using cryo-EM techniques. He has more than 25 publications to his credit in the field of biological and chemical sciences. So he'll be sharing his views on application of electron microscopy to biomacromolecules and emerging technique to structural biology. Up to you, Dr. Tapan.
Good evening to everybody, and I'm sorry for yesterday I could not able to attend the conference as well as could not able to present the talk. So I'm happy to be happy with the reschedule. I'm going to talk about the research which I did in presently. And though I have worked in many various areas, but I would like to present the new techniques, the cryo-EM, which has been emerging as the last couple of years in the field of structural biology, specifically the biomolecule that includes the RNA, ribosomes, proteins, big virus particles like COVID-19 virus. The first structure has been published by cryo-EM before we develop any vaccine or any medicine against this virus. Similarly, it happened, and a couple of years before that, people are struggling to get the structure of the viruses like Zika viruses before you develop a drugs. So having those kind of idea, getting a quick structure that can help us to develop a drugs for any disease or in futures, crime has been potentially gained a lot of attention across the world. So this is my topic, the application of electron microscopic for the biomolecules and emerging techniques for the structural biology. And how the electron microscopy we have been interested. As you know, there are light microscopy that you can see the virus particle. But in the light microscopy, you cannot see the analysis, the structure of the molecule because of the low resolution, like resolutions we can get around like 200 nanometers. But in case of electron microscopy, specifically, I am going to talk about the transmission electron microscopy. Though like other microscopy, you have a scanning electron microscopy. So in the transmission electron microscopy, we can achieve the resolutions around 1.2 angstroms, which is atomic resolutions, because the electron wavelength is 0.1 nanometers, whereas the light microscopy, the wavelength of the photon is 400 to 700 nanometers. And the basic difference in these two microscopy is that we pass the photons in case of light microscopy through the quartz lenses, but here we use the magnetic lensens to direct the flow of the electron from the source to the samples. So this is the basic diagram which are embedded in the electron microscopy, that is the transmission electron microscopy. We have an electron source, and that can pass through the condenser lens to direct all the electron coherently through the condenser aperture to the samples. And with the transmitted electrons, which can give a structure like not the scattered electron, where you see the morphology of any sample. In case of the scanning electron microscope, we transmit it, and that transmitted electron can be passed through the objective lenses and all the objective apertures, which can be magnified by an intermediate lenses. Like suppose you want to magnify it into like 80kx magnification, or 200 magnification, 150, 36,000, like that. So we can magnify it by lenses and get the structure in the projected lessons, the morphology, how it looks like. Then we analyze every image and get the three-dimensional structure of the molecules. So the transmission microscopy give you the brief, like the invention, like the first microscopy was developed in Germany in 1932. And then slowly it has takes a couple of years, like around 7 years, to get the real transmission microscopy that has been introduced. And people used before only for the material characterizations, but it was slowly adopted into the biological systems. In 1981, the first successful CRI-EM, that is transmission electron microscope, has been introduced, where we can see the structure of the biomolecules in the CRI conditions. Because we need to see the structure of the biomolecule in the native state. That is how we'll get the native state. We need to operate the biological system in the solutions. Like in the structure we get in the X-ray or in other techniques, that is not the native form of any proteins and RNA, because you will drive out the one thermodynamical state of the RNA or ribosomes or virus particle in case of X-ray. So to see the real structure, how it looks and what are the conformations are available in the biomolecules and how each conformation is acting is differently, that can be studied in the CRI-EM. So after so many years, the first Nobel Prize had been given to this kind of area in 2017, though it took more than like 40 years to get this. The area has been well defined in case of structural biology, though we have been working so many years on X-ray and NMR for various type of proteins and RNA to identify their structures. So why CRI-EM has been taken is so attention from the last so many years, maybe like 2 to 3 decades. And because we don't need any crystals to analyze the structure like we do in X-ray. And you also can get the atomic relations like we do in the X-ray. But in the X-ray, we cannot get various conformations of the molecules, which are a significant role in each state of drug development. So we need to compromise with the conformations in case of X-ray analysis, because we only like either you crystallize in room temperature or crystallize in 4 degree, that we thermodynamically dragging all form of the conformation into one form. Like in the NMR, we get a structure of the molecule in atomic relations, or also you can see the dynamic process, like every biomolecule in the dynamics. And that's how they perform the different biological activity. So we can find out the dynamics, but it's hard to get the real structure of various conformations. Like we did small proteins by resolution NMR. Whenever you have a large proteins, like more than 150 kilodaltons or 100 kilodaltons, we used to do by solid state NMR or a different selective leveling, like isotope leveling, ILV leveling, and then you get the structures. So the CRI-EM, but in case of CRI-EM, we can get resolutions of 2 Armstrong to 20 Armstrong, depending upon the systems, how it works, and the homogeneity and heterogeneity of the molecules, because we are working in the real form of the native form of the biomolecules. And we can orderly assemble them, isolate the particles, And also you can trap the transient state, which I was telling about the different conformations. And even if you have a not homogeneous, not pure, the samples, you can get the structure picking a particular form of the particles. And the key advantage of the cryo-EM is that you can directly image the molecule in the native form. You have a molecules, you don't need to crystals. You can directly apply the samples, image it, and each image can be analyzed and get a three-dimensional structure of the molecules. And you can identify the resolutions depend upon the number of micrographs, depend upon the number of particles, and how homogeneous your sample is. So small protein, large complex, you can do it, and also you can identify the multiple conformations. So I'm working in the Center of Molecular Spectroscopy, that is the Federal National Laboratory. We have been engaged in determining the structure of micromolecular complexes, that is like membrane proteins, viruses, and naturally occurring small compounds that bounce to the proteins or viruses. And we have been engaged with various particles like HIV kind of particles, cancer-related projects, and we do a high-resolution structure through a single particle crime analysis. What do you do in the crime analysis? You have a small particle and you want to achieve the atomic relations, we do the single particles. But sometimes we also do a cryo-electron tomography, where you do the like big virus particle like HIV particles, whether it is a mature HIV or a mutant. And also we do the cryo-electron diffraction, like that you got ED, electron diffractions, that method you can do ED, that micro ED. So how do we work in our most cryo-EM systems? This is the basic workflow we do it. We have a samples, and the samples which are purified, or sometimes it's hard to purify. What will happen? You don't have a pure samples. You cannot do NMR, you cannot do X-ray, but you need a structure to develop a drugs or any kind of future technology. So even if sample is not pure, you can take those samples, apply in the cryo-EM grids, and the cryo-EM grids, then you put in the microscope, the transmission resolution microscope, collect the data, that images, the two-dimensional images, and then two-dimensional images, you pick up the particles like the small black dot, and then you do the particle alignment and averaging, create a 3D models, and you define the structures. You can get a alpha helicid, beta sheets, everything, and get structures. And you can see the contact of the different residues with the small molecules or the RNA or nucleic acids. That's how we get the structure, which is similar kind of structure you see in the X-ray. So in basically, how do we we do the sample preparations? So I was talking about that we need to do the native form of the samples. So how we do? We have a sample, the solution, we apply in the cryo-EM grids, and we directly dip into the liquid nitrogen, liquid ethane, and we take out from the liquid ethane to the liquid nitrogen and store the sample in liquid nitrogen in the -80°, and image the sample at the liquid nitrogen and collect all the images, like you can see the particles. This is the general view I'm saying. And then we can take those particles, and the particles on the the cryo-EM grids, it sit in different. Somebody's in the floor, somebody in the 90°, 180°, all different angle. The all different angle image has been averaged, and you can get a three-dimensional structures. So this is the talk outline of my talk, that I'll be talking in 3D different systems having these techniques, that is 3D models of the hepatitis C virus E1, E2, and how its complex has been formed with the different antibodies, either is the monoclonal antibody, that is anti-E1, and also monoclonal antibody with anti-E2. And the second aspect will be the cryo-EM analysis of ATS ribosome initiation complex, how it affect the protein expressions, and also the MALAT1 triple helix RNA protein complexes, how it involves in the oncogenic activity. So let me go with my first 3D model of the hepatitis C virus heterodimer, and how it's so important for this virus. Everybody knows that you have a vaccine for the hepatitis B, but you don't have a vaccine for the hepatitis C. And 17 million people all across the world has been infected with this virus. And we don't have a structure, we don't have a drugs, we don't have a vaccine. Though we have a drugs that is the FDA approved drugs is DA, but it has some lot of drawbacks. So how the virus looks like? It is a virus, it's positive strand virus RNA, and mostly the virus replication is mediated by the two glycoproteins, which is dimer form E1, E2, and mostly the E1 is help in the cell diffusion through the endosomal diffusion, which help in the viral entry into the cells, and E2 involves in the viral replications through binding to the cell receptors. So as I said that the FDA approved drug is the direct acting antiviral drug against the target as HIV circle, but over the time, HIV also developed a resistance to this DA under the monotherapy. So we don't have an appropriate vaccine and drugs till now. So it is necessary to develop a drugs against these viruses. For that, we need to have a structural insight of this full length SCB1E2. Then we can develop a drugs. So the negative form of structural input can be advanced the designing of drug candidates for the HCV virus. So before I go like some of my interesting data, let me tell you what are the cellular studies says that there are different antibodies has been identified for the different epitopes of the E1, E2 virus. So as I said that you don't have a structure, full length structure. Somehow people have been able to get a crystal structure of the E2 core domain, the small domain of the full length E2, not the E1. And they found these are the antigenic regions, that is the discontinuous regions that have been identified with the AR1 and the antibody AR2A, AR3A, and that binds to the E2 only epitope. And another antibody they have identified the A4, which binds to the only E1 epitopes. And since we have a structure, if you see the structure of this E2 core domain, the frontal area is mostly the beta strand, and the back layer, which is mostly the like helices. And this is the CD81 binding loops, which is always inherent with this ectodomains. And these are the variable regions where it binds to the other epitopes. So with this structure, when you have a full length actual virus, that's E1, E2, can we find out some of the antibody that can help in the neutralization of viral replications? So what I did, first I took the different epitopes to understand the structure of these complexes. So we prepared a complex of the E1, E2, mix this complex, the A1 antibody and E1, E2, the viral proteins, and image it. You can see, so this is the negative stand image. So we do what you do before you go to the cryo. With the cryo condition, because of the bad contrast, we cannot see how the particles looks like. So we screen it negative stand through a staining agent, it's called uranyl formaldehyde, that gives a white background of the particles, that stain the particles. So this is the particles looks like. So after we see the 2D image, we pick up this particle and analyze through the software called the Reliance softwares. We pick up this particle and generate 2D classes. So first I identified the 3 antibody, which is we study in the cellular form, the cellular study, and then those antibody I image it and did a 2D classes. You can see there is a clear image of E1, E2. There is a E1, E2 ectodomains, the E2 core domains that binds to the Fab, and the typical form of the typical morphology of the Fab, like the dumbbell shape. And this is the ectodomain, and this is the E1, E2, the extended transmembrane domains. So we can see the 3 different epitopes have a different morphology. This binds to the end of the epitope, and this is bind somewhere in the stack regions, the middle of the ectodomain, and the other epitope binds to the end of the ectodomain, the E2 core domains. So, but we don't know the orientation of the molecule, orientation of the antibody with respect to the ectodomain, how it was oriented. It's hard to understand from the 2D classes. So to understand the orientation, I need to develop a complex of the 2 antibodies or 3 antibodies. So before I do, I try to understand how it looks like if I superimpose the two individual single antibody complexes, or we can say that I took the Fab, not the whole antibody. So because of the whole antibody has a Y-shaped, so I took the binding the fragment part, the Fab part. So I superimpose the individual Fab complex and see how the orientation takes place. When I superimpose the AR1B, AR2A, we see the 2 Fab are directly away from each other with the ectodomain and transmembrane domain. But here AR2 and AR3 as a second of one, like looks like 190 degree to each other. If this is the orientations or not, I mix these 2 complexes and analyze the image. We can somehow I pick up the particles and analyze the 2D classes. And what happened in 2D classes, in the particle, I mentioned that the particle is sit in different orientation, and all the orientation has been averaged, and we get a 2D classes. And from the 2D classes, we generated 3D volumes, picking the particles. So in 3D volume, you see, as you see the overlap, the superimposed model is consistent with our original, the verified, the complex which we generated. The 2 Fab is directed away from each other in case of AR2A and AR1 complex with the E1, E2. And similarly here 90 degree to each other, the AR2A and AR3A in case of complex with the E1, E2 full length hepatitis C viral proteins. Then what we did, how the morphology looks like. Here I have to tell you one thing, like this virus has the viral protein has very typical like thermodynamically unstable. So what we did, if we mix the 2 antibody together, the conformation is completely destabilized, and we didn't see any Fab binding to each binding to the ectodomains of the E1, E2 heterodimer. So we did a sequential binding. We first bind to the AR1B, then we leave it for the equilibrations. We believe that, we speculate it could be conformational stable first by the 1 Fab, then we add another Fab, then we that we did in the interval of over like 10 hours. And interestingly, we found these 2 conformations. Since it is very stable in the room temperature analysis, there's a negative stain analysis, then we move to the cryo. In the cryo conditions, we mix these 2 Fab and put in the solution and dip in the liquid ethane. Because why you do the liquid ethane? In case of transmission electron microscope like the X-ray, what you did, you have a crystals, you scatter the electron, diffracted the electron from the crystal system and get the structure. But in case of transmitted electrons, it needs to transmit through the sample. For the transmissions, your sample has to be, the ice contamination has to be amorphous. Like in case of X-ray, it's a crystalline ice, but in this case, it's amorphous ice. To get amorphous ice, we dipped into liquid ethane. The liquid ethane temperature is -60 degree. So in -60 degree, the water forms a amorphous ice. But if you put directly to the liquid nitrogen, the water, the buffer which is in the samples will be crystallized directly. Because of the rapid temperature down in case of liquid ethane, it becomes a crystalline. So you'll get only black dot in case of cryo. So to amorphous solids, you can pass the transmission electrons and we get the structures. So that is why you put the liquid ethane and followed by a liquid nitrogen. So liquid ethane can give amorphous ice on the samples. So we analyze the samples. You can see in case of cryo, and the image is quite consistent with our earlier observation in the room temperature negative analysis. And we can, with the resolution of 7.8 Armstrong, though we could not able to achieve high Armstrongs, and this paper has been recently communicated a week before, and it's accepted also. So with the resolution of 7.9 Armstrong, we can find the partial orientation of these 2 antibody AR2A and AR3A, similarly AR1 and AR1B and AR2A. And the orientation is somehow different. If you see in case of there, the orientation 180 degree in case of AR1B and AR2A in case of negative analysis, but here the orientation is around 115 degree. And this is the real orientation of the molecule that which we didn't see in case of room temperature, because we trap the molecule in case of room temperature with the heavy metal, that is a uranyl formate. But here we don't have any staining agent. It's the real form of the molecules. Similarly, it's not on 90 degree to each other for the AR2A and AR3A, but it's 45 degree. So that's how we understand the structure of the molecules, and based on that, we can identify and you can develop vaccine for these molecules. So then what could be the size of the molecules? Is it the molecule what we are looking the right size in the cryo or not? And we are claiming that each molecule is monomer. And to understand the size of the molecules, we did gradient sedimentation configurations, the cut profile. What we did, we took a different standard, that is thyroglobulin and globulin and albumin, and we measure the size of these molecules. And with this standard, then we run our SCB-E1E2 and SCB-E1E2 with the antibiotic fab, the E2 fab. And we found that the size of SCB-E1E2 without antibody is close to 100 kilodalton, which is the size of the we can say 150 kilodalton size of the globulin, that is this one. And this is the complex one, but only the SCB-1E2 is close to like in between like 100 kilodalton, and this corresponded to the 150 kilodaltons. That is, if you start from the here to here, the whole profile, it is a 150 kilodalton, and this could be the 150 kilodalton within this one. So since we have a orientation of and the interaction of E2 fab, mostly E2 fab, I showed the AR is the antigen E2 fab. What will happen? Can you have an antibody? Because when somebody infected with the virus, we can inhibit the viral replications through the E2 antibody, which is mostly involved in the viral replications. But do you have a vaccine candidate that the virus cannot enter into the cells? That means you need to block the E1. Then we try to identify a E2 antibody, but somehow we could not get it from the E1, E2. So we developed drugs that is called the CCG, the chlorocyclidines, the drugs, which can bind to the fusion peptide of the E1 part. So since none of the antibody is bound to the E1, in case of the whole E1, E2 homodimer, the heterodimer, we cross-link with these molecules to the E1, and then the cross-link molecule, before it cross-linked by the UV, it has been modified by the diazine biotin molecules to understand the antibiotic fab interactions. So we have the whole molecule, then cross-link with the EV, but we try to understand that what could be the power, the EV power that can be cross-linked without any side effect. So we did at 4 watt, we did 100 watt, and we did slowly the cross-linking, because to trap the intermediate of the small molecules. And in the 100 watt, it has been the EV cross-linking has been very slow, but in case of 4 watt, it is very fast. So in very fast, we cannot get the transient state of the fusion peptide. So we did over the 100 watts, and once it's cross-linked, this is the cross-link E1, E2. The site is different than the E1, E2 in the negative stand itself. And then we interact with the antibiotic fab that binds to the diazine molecule, the diazine biotin molecules. And we see the substantial interaction of the antibiotic fab to the whole E1, E2, which has been pre-cross-linked with the CCG, the modified CCG with the DB. Then we also bound to the AR1B fab. And interestingly, we see the 2 fab has been bound to the E1, E2, which we didn't see in case of the previous complex. Only you can see the 2 fab of the bounds to only the E2 part, and you don't have a fab bounds to the E1 part. So this could be a very good potential candidates for the drug development, since you have a small molecule cross-link through the E1, and you have antibiotic, you have a like antibody bound to the E2 part, so you can block in two sides to stop the viral entry as well as the viral replications of this hepatitis C virus. So in the summary of this study, we can say that the SCB-E1E2 bonds to CCC may be a potential candidates for the vaccine development, and also the data provide important information not only to validate the previous finding, also on the structure in finding. It also helps their native conformations, how it looks like, to understand and develop a drugs. And the E1E2 heterodimers appears to be exist in monomeric based on our sedimentation profile, and which is consistent of the main globular body, which is depicting the E1 and E2 transmembrane domains, and the protruding structures referring to the E2 core domain, which binds to the E2 antibody. So my second part of the talk will be the CRIAM analysis of the ATS ribosome initiation complex. And this is the most important project because, as you know, in the protein expression, the central dogma of the molecular biology is that we have a DNA, then you go to the transcription, translation, and then you get the proteins. So during the transcription modification, that is DNA to RNA, in that time where the messenger RNA is involved, that contributes the regulation of gene expressions, and the initiation factor assemble through the 7-methyl guanidine cap of the messenger RNA, and that is initiate the methionine tRNA for the translations. So the resultant pre-initiation complex that we form the messenger RNA and the tRNA interactions, that's complex, the pre-initiation complex can in the 3' end of the 3' end direction until the start codon of the AUG, that is this AUG, and then encountered through the association of the tRNA anticodon loop, and then it scan and the help in the protein expressions. So effect of the function of metabolic this translation initiation complex of messenger RNA upon interaction with the tRNA, how it affects if you modify the messenger RNA. And it's hard to, like as you said, that it's a big particle, it cannot crystallize. And then how do you understand the molecular interaction of the messenger RNA, tRNA, and you modify the messenger RNA, how the interaction is happening with the tRNA. So we have the samples, we can purify the samples with the ribosome, ATS ribosome. And so far there was structure only published the 60S ribosome or 40S ribosome. But the first time we could able to see the ATS ribosome interaction of messenger RNA, tRNA. So we collect the sample, image it, and we collect the 3D volume from the CRIAM images that we collected of 3D volume, and then understand the molecular interactions. We refine the local interaction between the tRNA, messenger RNA, and tRNA, and we found out the interaction of this tRNA and messenger RNA at -C1 positions through the hydrogen bonding. The interaction, and after the modification with the AC4C, AC4 is the small molecules, the interaction has been far away from tRNA to the messenger RNA, which was very close initially. Because of this interaction away from each other, we can control the initiation complex and the protein expression in case of ribosomes. You can see the interaction here is close to the C-1 and the tRNA, but this interaction has been far away from each other once it is modified with the small complexes, the small molecule AC4C. And you can see here also the hydrogen bonding is from this carbonyl and the hydrogen bonding of this OH group of T6 and the -C position of the mRNA, which has been far away once it's modified with the AC4C. So that's how we can control this initiation complex and also control the major contributions of the protein expression and regulated by the gene. So another third part of the analysis by using the CRIAM, that is the metal-1 triple helix RNA complexes with the proteins. And this MALAT1 RNA, that is the metathesis associated with the lung cancer endocrine transcript RNA, a long non-coding regulated gene RNA that can regulate the mRNA and protein expression that are similar to the ribosomes. But what will happen if this high level of metal 1 RNA in the human cancer tissue happen in the human cancer cells? Because of the off-regulations, it induces the cells proliferations, migrations, and invasion in the in vitro and tumor metastasis in the mice. But what will happen is down-regulated, that is low expression of the MALAT1 RNA that is happening that is found in the human cholesterol and breast cancer tissue and decrease the patient survival. So during the whole life cycle of the MALAT1 RNA of regulations or down regulations, the MALAT1 RNA bonds to the metal 16 for the proteins, other proteins, and because of the protein and contribute the oncogenic activity of this of regulation and down regulation and leads to the cancer cells. So how this binding had been happening? So still so far nobody knows how the structure looks like, how it binds, what are the domains of the which domains of the protein binds to the MALAT1 RNA. So this is the MALAT1 RNA dimers, and the RNA dimers we can see by negative stance, the white, the elongated shape, and we form the 2D classes. We can see clearly the MALAT1 RNA dimers. We always form the dimers, and one ends we believe bounds to the proteins, the metal 16 proteins. So once we mix with the MALAT1 RNA dimer, once the 2 dimer of the 2 different construct we design and mix with the protein, the metal 16 protein, and we can see which could not able to crystallize this RNA because of too much flexibility of this RNA and too much flexibility of these complexes. It hurts to purify with the size crystal chromatography and also hard to make a crystallize. Then you can see, but however, you can see in the cryo, the metal protein, the dot bonds to the RNA. And also the second RNA, which is the different construct of the MALAT1 RNA, that also binds to the metal RNA dimers, and you can see the protein interact with the 2 different end regions of the RNA dimers. Then we design the 2D classes, and then now we construct the 3D volume. So, but we never know. This is the one RNA dimer, one RNA, and the another RNA which forms a dimer. This is the kissing loop area, and you can find the metal 2 domains, but we do not know which domains is what, is the N-terminal domain or the C-terminal domain. But our MD simulation, we see the C-terminal domain is size is small and the N-terminal domain is size is big. And having that, we also identify the size of the 2 domains, and one domain is a bigger size, the N-terminal domains, and these are the C-terminal domains. And we believe that the N-terminal domain is always binds to the MALAT1 RNA dimers, and which is usually studied by the mass spectrometry and other techniques and also cellular study. Somehow we could able to isolate the cryo-EM structure of this RNA dimer, and we could not get the RNA protein complex because this complex is undergo like dissociation in case in the war-ether interface, because in the cryo-EM our conditions is that you have to play around with the water-air interface, and it's very sensitive. Many complexes undergo dissociation. That's why we do sometimes cross-linking, sometimes use different reagents to protect this complex, not exposed to the air. So in this complex, we had very difficult to get the both complex, but we only able to get the RNA dimer. You can see the RNA dimers, which is well defined with these cryo-EM structures. When this is the structure of the alpha fold structure of the RNA dimer, which can match the density, electron density, which is often from the cryo-EM of the metal 1 RNA dimers. So these are the structure you can see and understand how we can design the medicines or any drugs against this MALAT1 RNA, which is mostly the cancerogenic activity, or the virus RNA, hepatitis C virus, or this ribosome complexes. So cryo-EM has been a potential technique to understand this structure very quickly. And as I said, how it does we sample people. This is a typical called a vitrobot. We put the cryo-EM grids through the tweezers and apply the samples. It blot it because we have a buffer. We don't need too much buffer. Otherwise, it will be too much ice. So we need a medium ice, because ice contamination is very important. Is the TM. We need to blot it, and minimum quantity of the ice will be, the water buffer will be there in the samples. Then we plunged here where the liquid nitrogens, sorry, liquid ethanes. We have a liquid ethane that is cool downs through the liquid nitrogens. And once you dipped into the liquid ethane, we'll get a amorphous ice, which is in 100 minus 160 degrees centigrade. Then we take out this from here to liquid ethane and store the grids. And then you can put in the microscope. There's a different microscope in our facility, like Talos 120C microscope, where you can achieve the resolution of like 4 to 6 Armstrong. We screen it. Then also we have another microscope. We can achieve the Armstrong with 2.5 or 2.8 Armstrong. Even you can go to 1.5 Armstrong. But we have another big microscope, G4, the generations 4. This is the latest microscope. It's called Titan Crius. You can operate a 200 kilovolt with the field emission gun and Falcon server, electron detector, and you can achieve the atomic relations of the microscope. So this technique is mostly what I told is that you have a sample, you cannot crystallize, and it's hard to solve the structure by the NMR, because NMR is also restricted to the molecular depth. You cannot go beyond 150. But when you have molecule like 200 kilodalton, 600 kilodalton, like coronavirus, or like this is trimer, and one monomer is 180 kilodalton. We have a 500 kilodaltons. How we do the structure? If you do not know the structure, it's hard to understand the epitopes, which we can bind to the antibody and restrict the viral replications. So the crime is the best tools that we can determine the structure very quick and for the future drug developments. And this is our team. We have been working with our team with the chief. There's a chief, Sujan Lee, and she is from the Oxford, and our director and myself working as a crime microscopy scientist, and we have a data analysis scientist. We mostly analyze the different data. And thank you all, and I'm happy to take some questions.
Thank you, Dr. Tapan, for the insight that you have put into this cryo-EM. I have a very basic question about it. What is the sample size for cryo-EM? Because I can see from your although it has high resolution, but there is a signal to noise ratio. Signal to noise ratio is also high comparatively. So what is the size of the sample to which the sample which you will analyze on this?
Yeah, so that's why I said like it is the minimum size. We always prefer to be like, recently somebody has published, he published a structure of 50 kilodalton. Is surprised, but it's for me like if I have at least minimum 100 kilodaltons, it's good to analyze the structure. With the small molecules, you have a signal to noise ratio is very bad. It's hard to understand where is the particles. So big particles, you have very good contrast. Signal to noise ratio will be very less, so you can easy to pick up the particles and reconstitute all the images and get a three-dimensional structure. So the minimum size for me, like I believe, like I can work on minimum 100 kilodalton proteins. Less than 100 will be very hard to get high-resolution structures.
Okay. Thank you, Dr. Tapan. This is all from my side. There are a few questions in the chat box, if you can take.
Okay, let me check. Yeah, I can't find the chat box.
Oh, okay, no problem. I can read it for you.
Okay, now, yeah, I got it. Yeah. So I got it from the Jyoti that yes. So the question about this that are we liquid ethane free sample viable for the longer use? Yes. So once you freeze the sample in the liquid ethane, we always store. We cannot do immediately, so we store for like store in the liquid ethane, liquid nitrogen. That personally, like in my experience, that we can store for at least 3 years. Over the time, it get contaminated, but we can store for long, like 3 years. You can use this store it in liquid ethane for 3 years and use and scan like image the samples anytime.
Any further questions from Dr. Tapan? So I think, I guess we should move ahead. Thank you, Dr. Tapan, for this late night talk, because it's very
okay.
late over there. And we have kept you awake for your session today. So thank you again for being with us and presenting such a wonderful technique. Definitely, it's far better than resolution-wise, far better than TEM and SEM. And also, you can analyze the sample later on. But in case of TEM, it is not possible. Once you use it, it is not possible for keep it long. So definitely, it's a good technique.
Yeah, one
And
thing, like even if because you can freeze it, store it for a long time whenever you can, whenever you want to use it. But once you use the samples, we sometimes use the reuse it if it's a good grids, but because of the electron irradiation on the sample, sometimes we damage it. So we try to always use a fresh samples. If you like, you have fresh sample, you freeze it, keep it in the liquid nitrogen. Whenever you want to use it, once you use it, and we don't recycle it because of the damage of the sample by the electron beam.
okay.
Yeah.
Thank you, Dr. Tapan. Thanks for your talk. Dr. Jyoti is also writing to you. Thanks for your talk, although on our last day. Thanks for coming. Sorry. Yeah. Thanks for coming in the odd hours there and staying awake. So thank you, Dr. Tapan. Let us move ahead with the proceedings. I think we should now, I will hand over the proceedings to Dr. Rashmi for valedictory, and then we will be having means then only I think we can wait for lunch so that we can complete this proceedings, and then we will disperse for our munching. So Dr. Rashmi.
So we are about to end the conference, the 3-day conference. So we all know that science is the activity and application of knowledge and understanding of the knowledge and natural and social world. So everything around us involves science, and it has become a necessity of the present day. And over the last 3 days, we had deep insights into several scientific issues. We focused on the various scientific topics like indigenous knowledge of disease, its cure, prevention, sequencing of SARS-CoV-2 RNA genome for the identification of current variants, updated appraisal about the threats of aluminum in our life, bio-inspired engineering, and antibiotic resistance from hospital waste, and so on, various other topics. So many of the major challenges that are confronting us today needs to be approached through a scientific perspective, taking into account the social and ethical issues. We have to take, and now we come to the most awaited part of the conference, for which this is the most awaited part by the students. So society has introduced some awards for the young researchers to develop research temperament. And this is the, so, but before announcing the awards, I would like to say a few words that to the students, that success is not final and failure is not fatal. It is the courage to continue that counts. So who are the winners? Congratulations to the winners, and those who have not been awarded. That doesn't mean that your work was a little lesser than them. So I announce the award for the best oral presentation, which goes to Akanksha Roberts. Akanksha, are you there? Akanksha? I think Akanksha is not there. Best poster award goes to Komal Kashyap. Komal, I can see you, so I would like you to say a few words.
Thank you, ma'am.
Say something about your work, express your feelings. This is the platform to connect.
My work is very novel in my laboratory, and I would like to thankful to my guide who approached me to do this work. And also I acknowledge Dr. Surjit Ghosh, Dr. Hiraram Patel sir, who provide me to UV spectrophotometer facility, and also from IIT Dr. Surjit Ghosh sir, who provide me to XRD and SAM. Thank you, ma'am.
And so as the society for the first time started, Akanksha, I can see you also there. Akanksha, can you hear me? Okay. So as we all know that society for the first time has started the Sci Art competition, and that was merely with the intention to involve the graduate and the postgraduate students in large numbers, because they are our future. So it was the first time we have introduced, and I hope to make it successful in the coming years. So as of now, in the Sci Art, we acknowledge Astha Singh and Rupinder Kaur. Are you both there?
Yes, ma'am.
Okay, so congratulations from the society. And the appreciation award goes to Miss Aditi, Miss Manisha, Miss Medha, and Miss Saya Gupta, Saya Tyagi. So anyone of you would like to say something here? Aditi, Manisha, Medha, and Saya, please share your. Yes, Aditi.
Yes. Good morning, good afternoon, all of you. And I'm really happy for achieving the award. And yesterday, the discussion with all the eminent professors, all the audience, it was very nice, very insightful. I learned a lot from those comments that were positive comments that were given to me. And on my birthday yesterday as well, thank you so much all for your wishes. And then lastly, I'm very, very happy. Thank you for everything.
Manisha, Miss Manisha.
Yes, ma'am.
Yes, please share your.
Very good afternoon to all of you. First of all, I would like to thank who helped me a lot, Miss Dolly Krishnan ma'am, who guided me. And I like to thank Abricon-22 to express my thoughts here and giving me this opportunity. Thank you.
Thank you. Thank you, Manisha. Miss Medha.
Very good afternoon to everyone. Thank you so much for providing us such a great opportunity to express our whatever we learn, and it's been a very good learning in these 3 days. So thank you so much for that.
Okay, and Saya Tyagi. Okay, so now we move ahead. So the knowledge that has been gained here and shared through this platform I think will definitely achieve a positive outcome and prove beneficial for all of us. So I would like to ask if anyone would like to share their views or would like to say something before we announce the closure of the conference.
Hello.
Yes.
Hi, ma'am. This is Akanksha here.
Yes, Akanksha.
Ma'am, I just want to basically thank ICRIB. Like I had taken part last year as well and this year. And even though, yes, I know this time, like I think there were lesser people and all, but I honestly, there's like a lot of confidence. So last year, because of COVID, we didn't have too many conferences. So as a third year PhD student, this was like the first conference I got a chance to present at last year. And it was like a real confidence booster. And especially right now, finishing my PhD and everything, it's given me a lot of confidence presenting my work and actually having discussions. So I actually want to thank ICRIB for this. So it's kind of pushed me into actually presenting my work with confidence. So thank you very much.
Thank you, Akansha. Yes, this actually the motive of the society is to encourage students like you and to provide a platform to the students. So we started it during COVID when no one was allowed to move out. So, yes. And we hope to start this conference in physical mode very soon.
Yes, yes.
So, so anyone else would like to say something?
Hi, everyone. This is Jayant.
Yes.
Okay. First of all, I would like to thank Mr. Pranav Bhaskar and the other organizing members, committee members, to provide such a wonderful platform for our students who are working head to toe and working so hard in this science field. And we are providing such a good platform. So thank you, all of you. Thank you for the participants to make it a huge success. And this gives us a huge encouragement to conduct more conferences like this. Thank you so much.
Thank you, sir. Anyone else? Okay, so over to Dr. Pranav.
Thank you, Dr. Rashmi. If I will have to thank anyone, then I will have to thank each and everyone, because each and everyone has made this conference to happen. I don't say successful, because if I say it's successful, then I will not try for the next year. So I will say yes, it was a good conference. People have participated and motivated me and the organizing team of Abricon-22 to think of going in physical mode. And so definitely we will try, whenever we will come up with the next conference, it will be in physical mode. And I would like to thank Dr. Rashmi Tripathi for taking this conference as a challenge, because I have loads of work, and at that time I was thinking not to continue with organizing this conference this year, but Dr. Rashmi gave me good support. She supported me throughout, and she has been instrumental in organizing and talking to resource person and in managing everything along with other organizing team members. Her coordination with me and other organizing members has made this conference to what it is concluding today. So thank you, Dr. Rashmi. And I would like to thank Dr. Saroj Kumar Jha for being a co-convener and convening this conference. I would like to thank Dr. Jyoti Bhojwani. And on top of it, I would like to talk about Dr. Venkatappa Rao sir, Dr. Ritesh Shukla sir, and Dr. Pranav De sir. These three have motivated me every time to organize such conferences, workshops, and they have been a huge support. I cannot think of moving ahead without their kind support. So thank you, everyone. I would like to thank Jayant as well. He has been a pillar. Whenever I fall short to something, he had always been a confidence to me, and he had supported every time. I would like to thank Dr. Napreet Kaur here. Uh, she has been busy with things, but still she had been a pillar. She had been supporting me. Whatever I do in my life, she has been supporting me. So thank you, everyone. Especially, I would like to thank young researchers like Rupinder and Astha and Medha Kumari and Manisha Rao. They have given us a glimpse that what our future in science could be, because they have started working on certain challenges, certain challenging topics. Those actually boost our morale that yes, this is not going to like end. They are the bearer of light, and they will be taking us ahead in the field of science. So thank you all for making this a support. Thank you all. And with this, I would like to conclude this conference. Still, I would like to ask, we have Dr. Nayak with us. So if Dr. Nayak could say a few words to boost our morale again. Dr. Nayak.
Sir, good afternoon all. It's nice. Actually, I have already shared my views. That's why I was not coming in. It's really good, but I hope that next year onwards it will be even better. And I agree with Pranabji that if we think that it is successful, then we are done with it. We don't go for further improvement. So let us see. I think we will meet again in the next conference with a lot of improvement and lot of participation. All the best to the society, and thank you all the organizer. It's a nice and really hard work was there behind the scene, behind the screen, and we should appreciate that, and we could understood also that. Thank you all.
Thank you, Dr. Nayak.
Thank you, sir.
We have one of the scientists from Serbia, Dr. Snezana Anzelkovic. So let us welcome Dr. Anzelkovic. Dr. Snezana, are you with us? I think let us move ahead, and thank you all for supporting, for being the part of it, for making this conference to what we are concluding, and for doing good science. So doing good science never means that you do something to publish a paper or to get recognized for what you work, but doing good science means the science that you are doing for transformational and sustainable development. And if you do so, I think you are doing good science. Thank you. Let us conclude over here. And sorry, in virtual mode, we cannot provide you food and lunch, but definitely when we will go on physical mode, we will be having fun. We will be having scientastic fun. So thank you all. If you want to share your feedback, you can write to us to our email IDs, email at icrib.org or Abricon-22 at icrib.org. Krishna, you had raised your hand. Sorry, I skipped it. If you want to say, you can say, please. No? Thank you. And also, if you want to join ICRIB as a member, so the link has been shared in the chat box. You can, I'm again sharing it in the chat box. You can click over there and fill in your registration, and we will be in contact. Besides that, you can visit icrib.org, and there in the membership section, you can go and register yourself. Thank you all. With this, I hope more and more members and more participation in the next conferences. Bye-bye, take care, and keep doing good science.
Bye, everyone. Have a good day.